Okay, so last time we checked pretty much the final function in our game loop, and that did some stuff with skull mouth movement, updating of tiles, which was weird because we do not, I mean the skulls are sprites when we activate them. So this function alternates skull tiles when activated does not really make sense. We're doing an update tile at position. So the thing I could think about is clearing the tile when we move around, but that doesn't make sense either. So we tried removing this function and it did nothing when it came to skulls moving. So I'm a bit confused about this specific function. It's quite weird. So yeah, we're picking the correct skulls based on the odd-even timer, or the timer being odd or even. And yeah, we're updating tile IDs here. So we're alternating next skull tile ID over down here. It doesn't really make sense because we're not using tiles. So the moment the skulls start moving, they are sprites, right? So let's go look at this level here, 2 before exit, no, 2 before last hard framer. So if you look now, I think these aren't sprites yet. So now there's no sprites here, no skull sprites. But from the moment we activate them, they appear, right? So they're turned into sprites. But from that moment on, there's no, like the mouth movement, it happens in the sprites, not in the tiles. So I do not know what is going on here. Whether it's a remnant of, like that they forgot to remove or something, I'm not sure. It doesn't make sense at all, though. I mean, I'm sure it has a reason, but because if you go look, I have to go back because of course it jumped away. So if we go look here, this function detects whether the AI has started and whether there are skulls in the level, so the AI has to start, and at that point they have been moved to sprites. I mean, I can try removing this one, but if you look at this, I'm going to activate this again. So we're setting tile ID at this position, right? So first parameter is in the accumulator is the tile ID. BA, we know that BA comes from this one, I think. Yeah, this one. So that's 186, right? So if you go look in the tiles, 186 is in fact the start of the skulls, I guess. 186 is the bottom left of the mouth of the skulls, closed. Right, and it alternates it, so it XORs the 6, so by 2 and 4, or representing 2 and 4. So if you do that, I think we go to BC or something. So we have BA, and we XOR 6 out of it. We get BC, right? And BC is of course 188, which is. And then that's also weird. It's the next two, which is the top left of the red skull. And if you look at the position, let's activate Open MSX here. If you look at the position, that would be in HL, I assume. That's 2802, right? So those are tile coordinates because our skull is So in this struct, they are at xy, not yx. So y is 2 here, meaning, yeah, that's like at the top. So we're talking about this skull here. Unless update tile at position does something else, but if we looked at it, right, and so it loads activated skull pushed block tile top left. That's also a weird variable. Like if you push something like a block, that gets put in this variable d1e6, but I need a better name for that. Like that's this guy here, and there are like 4 positions, right? So this denier and then like a complete set of tiles, like 4, top left, top right, bottom left, and bottom right. I mean, maybe it is not exactly update tile at position then. Let's see. So, because what we're doing here is we're prepping these values, I think, right? So we're loading the pointer. No, yeah, we're loading the pointer into ix. So let's stop here. I'm going to go in because we are currently above this function. We're going to go in, right? So we're loading BA now as our input, which is the accumulator. We're pushing lots of stuff on the stack. That's fine. And then we're loading the pointer to this here, those 4 sprites, into ix. So that should be d1e6. Right. So ix points now to d1e6. We load the accumulator, which was BA, which is the value over here, next skull tile ID. So that's the tile ID parameter from the function, right? So we're loading that into C. And then we're putting C. Okay, so we're taking the next 4 tiles, right? Because we're inserting C into where ix is pointing to. 4 times, and we're incrementing C every time. So we're starting at BA, so it becomes BA, BC, BD, and BE is going to be put in these guys here. So let's do that. BA, BC, well, BB, BC, and BD, right? And the last one. Okay, so now we put BA. So let's look at that again in the tile viewer, because there was a discrepancy between where the Kirby, where the tile started, like at the mouth or at the eyes. Welcome. So yeah, so we are at BA being 186. So we're at the mouth here. So the 4 tiles we have loaded here are the 2 bottom closed mouth pieces and the red skull eyes at the top. Not in order, right? Which is also quite weird, but sure. Right, what do we do then? So we're checking whether A is empty, which it is not, of course. And then we're comparing it with a whole bunch of values, and this one is going to match because we have BA. So we're going to call this function, okay? Yeah, so this function might be more involved than I thought. Let's see what happens if we go in there. Yeah, we're ANDing A with 0. That's not the case. Comparing it with 1, nope. Well, so it's not going to call, right? I'm going to go in and it should hop over. Yeah, it does. So compare, hop over. Where's BA? No, BA is here. So we're going in this function, 669A. 669A is going to go here. Okay, so these guys all do certain things. So this might fix it though. Exactly, it's going to put them in order. As in, it's going to put the eyes first and then the mouth, right? So it's going to load the accumulator, which is BA, which is our starting position, in the third element, and then increasing to BB, putting it in the fourth, then B. Okay, so it's going to put BC, BD, BA, BB in these four guys here. Okay, so it adjusts. Okay, so this function name is incorrect. It reorders the tiles, and it does so for a very specific amount of tiles, right? So this name is completely wrong. So, and we do return after this. We call it, so we come back though. So we're comparing. We're not going to do that, and then we're calling something else. So wait, we might still put it on screen, but it has to be in some of these functions then. Right. Okay, so we'll have to look at that. So yeah, these functions at first prepare or fix the order, I guess. And these are the exceptions, right? So BA has to be fixed. I'm going to let it fix it. Wait, so let me jump over this. So this jump is going to be taken, and it's going to change these four guys here to BC, BD, BA, BB, I assume. Right? BC, BD, BA, BB. So it swapped them around. So yeah, for all these 1, 2, 3, 4, 5, 6, 7, 8, 9 exceptions, there's some jiggling about, like it's reordering based on whatever, right? We only looked at BA, which we can give a name now. So 669A. Okay, we don't have a 66. 2, 4, 4, 5. Okay, here in between these guys. So we have 669A, was it? Yeah. Is reorder closed mouth, red eyes, skull tile set. So it fixes incorrectly ordered tiles. Well, I mean that's implied. Okay, so reorder closed mouth, red eyes, skull tile set. Fixes order in D1E6. So that top left tile is first. Okay, it goes top left, top right, bottom left, bottom right, and those have to be swapped. All right. I'm going to look at the other ones now, because BA is for skulls, right? So let's look at what the other ones could be. They probably also need fixing, or like fetching completely different tile IDs. So yeah, B2. To go look, B2 is 178. Okay, so we have top left bottom left and 2 eyes, so that's not correct. So we have so it has to be these two guys. Is that, no, that's not the correct next one, right? We need this one, and then the 2 feet. Okay, so let's see what it does for B2 668D. Oh, it loads hard-coded values into the second one, increases, puts the A6 into the third one, and A7, A5, A6, A7. It chose to use increment to convert to A7. That's weird, right? Oh, well, no, because the accumulator is given, right? That was, what was it, B2? No. Yeah. So B3. So we end up with A0. No, wait. Which one was it? Crap, I forgot. 668D. Yeah, so we end up with B2, A5, A6, A6, and A7. No. Right, let me write this down. So we start with B2. That's in 0, right? In 1 becomes A5. It increases to A6, which we put in the third one, and then we put A7. No, A5. No. It becomes B3, and then A7. So does that make sense? Let's see. So we start with B2, which is the left-looking top left. That should be. That's 178. That should be in top left, and then A5, which is 165. Yeah, that's the top right of the left-looking goal. Yes. And then B3, which is the next one, which I assume is this. That looks like it's the bottom left. And then A7 is going to be this one. Yeah. So it has red feet at the bottom and a bit of... Yeah. That's the entire body. Okay. So we can give that one a name too. Yeah, so we're talking about 668D. Well, I mean, it's the same comment for all of them. Fixed reorder, left facing active call, was it? Active call tile set. And then we have, so that was B2, then B0. That's going to be this one, right? That's 176, is that correct? Yes, that's activated to right. And that calls 667D. Right facing active goal. Then we have 70 hex. That's 112. Oh, that's the brick wall. 112. And it starts, it jumps to 6675. Okay, so it loads that, okay, so we have these two guys, 112, 113, and that becomes then 112, 113, and it's that was this one, right? Already 6675. Yeah, it loads again, it duplicates simply. Yeah, because there's only two tiles here. Yeah. So 6675. And then 4. Okay, that's the bridge. It's weird though why they have to be fixed, as in that's top left, top right. That's not bottom left. That's bottom right. Oh, that's weird. Like you have top left. Oh, but they have to be rotated perhaps? Wait. You have top left, top right. What's this guy though? Oh, that's top right of I guess yeah, it's 2 for a horizontal or a vertical ladder, and these 2 for a vertical for a horizontal ladder. Yeah, of course. So it's 2 and 2. There's two sets here. So 4 is a vertical ladder, right? And we should have 6 as well. Yeah, we have 6 as well. Wait, I did that wrong because the brick tile. Oh, it's the same function for brick wall and vertical ladder. Okay, that does make sense, of course, because it's the same procedure, right? So for 4, it's this one as well. And 4 was a vertical ladder. And then we have 666A, which is horizontal ladder. Okay, I removed everything here. Why not? Okay, that's weird. Of course it does. I mean, I accidentally click remove all. And now it won't load it again. Okay, crap. Let me restart. What is this nonsense? Okay. Symbol manager reload file. Of course, my F12 doesn't work here. Symbol manager. Load symbol file. We are in the generic thing here. Why would that not be the case? So we're parsing each line. Okay, it skips all over because my formatter is on. I need to recompile. So let's quit you. I don't know why it does that, but how did I recompile this? I think it was just make. Yeah. Derived. Okay, and home stream. Okay, that's same file. That's impossible. Are those symlinks? Can't remember. Yeah, I put a symlink there. Okay. Yeah, of course I put a symlink in the thing. So let's see if we do get output now. Once we load our symbols here. No, we do not. Why would it not? Token size. Let's see. Oh, no. Oh, I don't need to install. Okay. Let's get our terminal here and let's load the symbol file. Like it jumps over that completely. Are we even in this function though? Maybe something's off with the detection. I mean, I'm probably made a mistake in the symbol file though, because if I will look at, yeah, it starts with a semicolon. Perhaps that's a problem, but it should have had that problem like from the start though. Like I don't understand. We are not. I mean, I am sure I'm in the correct one though. I have to check. So this is load symbol file. Let's dump that one too. Just to make sure that we're looking in the correct file here. Yeah, so we're in load symbol file, but we're not going to generic. So then the question is, are we here And if not, what is the type of type? Okay, that's an enum. Okay, that's fine. Maybe format can work with it. No, it cannot. Wait, so that's using enum symbol file type. Right, that's it. Oh, it's an enum class. Oh, I need to do your underlying type, I guess. I don't know that by heart, but I think it was something like underlying type. Do we need to specify the thing here? I think we do. Symbol file type of this. Does this work? I can't remember the syntax for the underlying type stuff. Could not convert type from symbol file type to underlying type implementation. Okay, why can't we? Okay, never mind then. Let's and then let's just do it like this. HTC, why would it do that? So what do I have in my file that makes it thinks it's HTC? Because we should have generic though, like detect type. If it ends with sim. Okay, we're falling through here. If line starts with, okay. So it doesn't start with semicolon symbol table. It should find this one. Oh, it's the first line. Okay, okay. I think it's the first line. Oh, crap, that means I can't do... I mean, I can put... equals... Like, is it... I don't know why it's failed on that and started to fail on this now. Yeah, that's crazy. So, well, I mean, I didn't add this first semicolon like now, right? Weird, very weird. Yeah. So what did it give the 0 a name? Wait, let me put a breakpoint here so I can go back to that easily. Yeah, of course. I mean, I have to, I guess I can do it like this. Yeah, then nobody knows. Okay. Let's go back to the breakpoint. Right. Oh, we didn't break. That's fine. Oh, yeah, of course we were here. Where were we? These guys, the reorder guys. Unless I better made it a bit bigger. Yeah, so we have our reorder functions here, and we had a couple left, right? So 6 was horizontal ladder, 4 is vertical ladder or the brick wall, and then we have 1. Let's go look back in the sprite viewer. No, the tile viewer. And 1 is... Wait, 0 and 1 are black. Is that an empty tile perhaps? And then we have 0 also. So let's look at 665E. 665E. Wait, what? 665E calls here. 5E is this one. Load 0101 in DE. Oh, okay, it is doing something, but with an entire 16-bit value. It looks like, okay, don't. Yeah, we're putting 0101 into top left and bottom left. Wait, top left and bottom left. Yeah, that's like the first one is top left and the second set of 2 is bottom left. So we're putting 0101 in there, and then 0000 in the, in case it's 0 here. So there is a difference between tile 0 and tile 1 though. Like this is 0 and this is 1. So these tiles here are indeed different or differently interpreted, but I don't really know why, but that's fine. Okay, so reorder is the wrong word, but like let's keep it in the same trend. 665E. Fills 4 bytes of this with 0101, and then oops, and with 52 it's with 0000, and then let's I'm gonna call this fix empty tile set. Well, this is tiles 0 and 1. Let's reload that. Okay, so that's 0 and 1. Okay, so we fixed our temporary array here, which is not going to be this stupid name. It's going to be like more than that. But let's see what happens after, right? So we are reordering here. Why? Okay, so yeah, is this guy here? Wait, 5C we didn't do, I think, because 5C is 92. That's water. Where are we? Oh, that's one thing of water, and it's going to make it like 4 tiles of water, I assume. 66AA is this one, and that just puts 5C all over those 4 bytes, right? No, I want this bigger. Okay, these are very finicky. Yeah, okay, so we're putting 5C everywhere. So 66AA is the last one, I assume. Yeah, that's for 5C. Okay. And then it's like fix water tile set. Stupid fly. Water tile. Five C. Okay. Okay, let's see what happens after then. We're calling 658F. That's a bit above here. 58F. Okay. So we are doing some math on the values of, wait, we're adding 1800. That's going to be the name table here. Okay. We're going to add some, like we're offsetting that. Let's see. Okay, let's go in. Let's go in. Where are we? We're broken. We're right here. Okay, I don't know which tile we're doing. We're doing D4. D4. Let's look what we're rendering. That's 212. That's low facing down. Okay, so we're doing low now, which interestingly is a sprite. Even though, okay, so yeah, I think we might be updating the sprites with tile contents, which would make sense though. Like where else is a sprite coming from, right? Okay, let's go in here. So yeah, D4 is Lolo's front-facing top left sprite. Our things here are D4, D5, 6, and 7. Okay, we're going in. DE is being pushed away, that's fine. We're loading 0 and... Wait, what is in H? That's 34 OE. Is that my location? No, doesn't look like. Because we're at 0620. 34OE. Okay, wait. So we're pushing away DE. We're loading 0 in DE. And H into E. I have to look where H is, what is HL pointing to. Then shift right of E. Okay. So 34 becomes 1A. I think that's just division, right? So 34 over 2 is 1A. That's correct. Becomes 1A. So we're shifting right. We're dividing by 2. We're loading 0 into H. Sure. And then we're doubling H. But the entire thing though, like it's OE now. Okay, we're doubling again, and then we're adding that to DE. Sure, that's FA, and we're adding that to 1800. Okay. Right, 18FA. So we calculated an offset in the name table, I'm assuming, but let's look what HL was before we call this function, because we're returning anyway. HL was already set when this function was called, I think. So we have to look outside of this function. But in any case, we are like, I mean, this 1800, that has to be relevant, right? So it's, let's look what that is in the name table. I think, is it main memory, or is this, do we have a different piece of memory here? But there's no tile stuff here. And it's not VRAM, right? It's I think it's main RAM. So let's look at 1800. Yeah, we're not going to be able to like figure out something here. But I'm not sure if I'm looking in the right location though. So we calculated 18FA, which is now in HL. And we are loading, so IX is still pointing to our guys here. Yeah, that's the fixed array of 4 tiles. So we're loading the first one in A and calling a function. Okay, there are 4 different functions, it seems. Well, no, it's 2 and 2. So top left, top right, and then bottom left and bottom right are, so it's left, right is, no, the left ones are the same function and the right ones are the same function. So let's see what 6B33 does. So yeah, we have D4 in the accumulator, okay. We immediately call a different function here. And we are, well, no, we're returning here, okay. So we're calling something increasing HL, which was the calculated number into the name table, I guess. And we return. So let's see what 66C2 does. Okay, we're pushing some stuff. Our friend D1FF appears again. We have function pointer offsets. Well, we're jumping conditionally based on, yeah, so the DC. So we're jumping to either these two guys. Oh yeah, so for 2 out of 4, we are adding HL and DE together, and for the other one we don't for some reason. Okay, so we're pushing something, base of 300. Is that known? No. We're loading A into C, that's fine. Anding A with FC, so we're dropping a couple of bits. Comparing with E8. Okay, so this isn't super important, I think. We are calling this guy. Again, okay, 1800 is another base, or the same base perhaps. And then we're loading the position in the tile map. Oh, you say, yeah, this might be inserting it into the tile map perhaps. Because we do have to update the current tile map as well. Fine. And we're putting A into where HL is pointing. C918. Oh, which would be the offset within the tile map. So that's what our tile map function returned, I guess. Yeah, because this adds some stuff to HL. Right, so yeah. So we're going to add or change something here. But seeing as we're not moving, we're probably not going to change anything. I don't see, well, no, Lola wouldn't be appearing here, of course, because that's not, like, it's not a tile, right? Although he is there, okay, sure. He is actually there. So we're checking our mystery variable, okay. Okay, I should have jumped out because now I recall the system function here. Okay, no, we jumped too far because now we are in a different function. I need to go back to here. Yeah, we looked at, so we have 2 sets of 2 functions here, right? So this is going to, I think, insert it in the map. We saw that, right? We saw it inserted in the map. But the question is, does it do something else as well? I guess it updates the map at that position with those tile, and it reorders the tiles when necessary. and whether it actually, I mean, it doesn't have to output. This is for collision detection as well, right? So you see, wait, are these sprites, these almas? Yes, they are. So both Lolo and the almas were sprites, because you saw him moving up, right? But I didn't see Lolo. Okay, start again. Right, you see the, yeah, you see the Alma moving, the two Almas, but I don't see Lolo, and I mean he was in there though. Yeah, I think this function updates the tiles in the map. So does that mean that there is no collision detection anymore if I disable this function? Okay, right, let's try that. Because what I think is happening is, instead of update tile at position, this is I think going to update, does these updates in the map. This big array is like a representation of all the tiles, the 100 and, wait, so 11 by 11 times 4 tiles in the entire map. It's updating that, I think. And I think that is used for collision detection as well. Right? So if I remove that from the game loop, we didn't see any change in the movement of the, or in the representation, the visual representation of the skulls, because they are sprites, but it might remove the collision detection. So let's see if that's correct. Okay, so, and this last one, alternate skull tiles when activated, right? This function only looked at skulls, right? So we have to have our triggered AI started, like the level has to be in end mode, like in the exit is open. There have to be skulls. It looks at the odd even timer for the skulls to see which ones to use to update, and then it uses it alternates between open and closed mouth, and then it updates the map at position with this tile ID. Okay. Right, and then so let me go here, these 4 guys here. No, where are we? Yeah, these guys here, activated skull push block. These are placeholders for the 4 tiles we have to update into the map. Right, so we have 4 temporary variables here, or temporary bytes, 4 bytes, and those get copied into the map, and the function update tile is actually update map at position, and it will insert all 4, I think. I mean, we can check that. So updates 4 tiles based on the first parameter. Yeah. And the XY location is provided in HL. Okay, makes sense. Okay. So what I'm going to try now is, if we remove this function, does that remove the So it will still update the sprites, but it won't have them in the map. And that might prevent collision detection. So I'm going to try that. Let's get ourselves a fresh copy of the ROM. And then we will open the hex editor and make the same change we did last time by removing the call to that function. Okay, CD835C gets removed. Reload a level in hacked state with skulls. I guess this one is easier. Oh no, I have one here. That is ready to go. Okay, so we don't have that function anymore. That's good. Wait, I'm gonna disable this one. Okay, our knobs are here. I'm gonna take this one. My question is, am I vulnerable to these guys now? So if I go look at the map again, where's the map? I mean, I guess I'm gonna find out because he's gonna hit me. Yeah, tile map. Oh no, he's still coming at me. Yeah, he was still coming at me. That's interesting. Was it changing though? Because it might, this last function might just simply do the update, close and open mouth, even though that has zero relevance for hit detection, right? So let's see if we can go to the same one. Yeah, so they are just BC, BD, BEBF. So they're not alternating anymore. And I'm going to do the same thing in the regular ROM to see if they do alternate now. This one. Yeah, you see them alternate, right? So that you see the mounts move. It goes BEBF to BABB, and that stops happening. But why is that important enough for them to include into the function? Like the first function, like we have a function that inserts or updates the position of the skulls. That's higher up in the game loop for sure. Skull selection. Alternate skull tiles when activated. Something calls this update map function. And then this little function at the end, which we removed, it was this one, right? Alternate skull tiles when activated. Just updates these skulls here to be the correct tile representation. But that has no effect at all. Other than it being actually correct, but I wouldn't know why that would be. Like what happens if you shoot them with a bullet? Does that affect things? I guess not, right? But at least we've confirmed that that is exactly what it does. I'm just figuring out if there's a reason as to why. So let's try some bullets. So we're in the hacked ROM now. Let's confirm. Yes, we are. Yeah, that does not make any difference. And if you look at the map, the egg is here, and it just became like a skull again. Right, E0, 1, 2, 3, that's fine. They come back. Oh, wait. They aren't moving their mouths anymore. Was that the case yesterday or last time? That's weird. They're not moving their mouths anymore. Okay, so why did I not notice that yesterday or last time? That doesn't make sense. I'd have to go watch that back to see if that was actually the case. Because, so now, I mean, it's actually doing what we think it does, which is animate the mouths. Did it not do that? I probably didn't see that. Then it was the last thing we did after like 4 hours of reverse engineering here, so I might have overlooked that. But yes, it doesn't. If I remove this function, it doesn't animate the mouth. So that's exactly what it does, and that's what the function says it does, right? So let's go back to the regular one. Yeah. So alternate skull tiles. This means activated skull mouth movement. Yeah. Yeah, it actually does that, and it makes sense looking at the looking at the function here. It alternates the skull tile IDs, it updates the map, and then the sprites are taken from the map, I assume, based on the tile IDs. And then here we're alternating the skull IDs, the mouth open and close movements. Yeah, makes perfect sense. All right, so we did clear that up. That's good. Yeah, 4863 we didn't know, right? 4863. Yeah, we looked at this a couple of times. 4888 was also curious. Yeah, we're loading 3 bases here. And again, calling some function 897. 897. Oh yeah, it calls this. Oh, and a 4D is called. That was. What was that? Writes into VRAM. Okay. I do want to take a look at the password screen thing. That should be here, around here somewhere too. I'm assuming a bit above here, because I want to find the passwords in the ROM, and I want to see what function gets called to launch a specific round, to see if we can do the same. I mean, it's going to come down to filling in the correct value in current level. Where are we? Yeah, current level here, and then jumping to a function, I'm assuming. Because if I change it here, that doesn't affect it. I mean, updates it on the screen, right? Which is, this isn't BCD, this is plain hex. But then it doesn't, like it will move me to level 18 when I exit. But I wanted to jump immediately, right? So we're moving to 18 now, so that does work. Because it's just incrementing a loading, right? But I want to see where this gets checked and loaded. However, the function or the place where to check that would be the password screen, because that jumps to different levels based on what you enter as a password. So that would be interesting to take a look at. And I'm going to see if spacebar pressed is called 6C3A. I'm going to clear some stuff here. 6C3A. Right, so we'll see if this one, of course it doesn't. We have should act on spacebar pressed is the 007. Is 0. Okay, so that doesn't work in this. Okay, so I can't trigger the input through that one either. Let's see what else changes. No, not here. I want to go here. Okay, I don't see any changes. I mean, we have some timers here, probably for the alternating colors, perhaps. It goes too quick. I mean, it counts from 0 to FF, right? So perhaps that's taking the color from that. But yeah, let's see if we see movement in memory. And now we're too high, I think. Okay, over here we see multiple things change. But it's dependent on which button I'm pushing, so it's not really one variable that indicates which one is selected. So I doubt it's this one. Okay. Okay, we have some maps, that's fine. And nothing after that. So how can we figure this out? Okay, now we're in basic. Okay, no. So let's go back to those 4 bytes that changed. I'm too high. Okay, here they are. so 77 to 17. Yeah, okay, so it is indeed position, or the... Wait, and if I go... Okay, so it's X and Y coordinates then? Wait, so let's see. So Lolo is 1730. So if I make this 1730, yeah, I do go there. And then what's this guy? 3, 6, 9. Okay, that doesn't change it. But if I move this to 3 and I go up, it goes here. Why so complicated? So 1730 is Lolo, 1748. So let's see what those values are in decimal. That's always a bit easier. So we're looking at 23. Lolo right facing is 17, which is 2330, which is 48. 3 times 16, of course. But it stays, so this is an X coordinate and that's a Y, well, no, because, yeah, so no, Y coordinate and X coordinate. Okay, so I'm gonna give this a quick name, D919. Correct, right? D919. Password screen Y selection chord, no, selection Y chord, and then the next one is 1A, which is the X chord. Right, so that's these two. We have our Y, which changes, and then we have X next to it, which changes too. The values are a bit weird. So what's the interval here? We have 30 and 48. So we have 30 is, well, that is 48, and 48 is 72. A difference of 24. I'm assuming these are the timers for the alternating colors. So let's simply put a breakpoint on this so I can give those a name as well. Or a watch point on D91C. Okay. D920. That's this one is also being, okay, so we're addressing lots of stuff here. D97C, that's this one. And that's the last one, because here we have the initialization map data for arrows and bridges. Okay, so this one is already relevant. So let's try, let's first try this one, see what that does. If I put that on 0, that doesn't make a difference, it seems. I am going to select one though. That became 9. B. That skips 2 each time. Unless, okay, and now it goes down, right? Now if I pick a different thing, does it become 9 again? Yes. And if I, yeah, so that's, why is it such a weird value? It starts at like 7. And if I put this on 9 now, does it fill in the second thing here? It does, right? Because I think that's the second. Yeah. So this is the next open position, but it starts at 7. Is this a Y core? No, that can't be a Y core, right? Because if we go look, well, no, because they don't even match. Yeah, they're offset here. So the or the X chord I meant, the X chord is 30 here, and it would be 7 here. So yeah, this is next D918. Password screen. Is it next next entry slot or current? I mean, that's a bit weird, but let's give it a name nonetheless. You can always fix it later. I was looking at this D91C alternating thing here. So we're loading the accumulator, which is 0E, into that timer thing. This seems to, I mean, we have this in a pointer, right? So why would we have that in a pointer? D91C is our value here. Okay, we're loading the value, we're incrementing, ANDing it for some reason. So we're not we're dropping the base 4 bits though. Oh no, and that we are loading in D920, which is this one. Oh yeah, okay. So we're taking the lower 4 bits and we're dumping this into D920, which is the same now because the top 4 bits are 0, so that doesn't matter. But we're copying that. Are these the right? I think these are the colors, as in we only need the 4 lowest bits because we have 16 colors, right? So yeah, this is a simple counter, and then we chop off the top bit and use only the bottom 4s because that's a number between 0 and 15 included, which represents the color of the thing. I think here. So I mean, that's easily tested. 99AA. Let's knob that out so we don't have. No, I'm going to remove you. Copy here and get the hex editor. A quick test. So I'm assuming that 0 is going to be black, so probably it will remove all the flashing colors. Or I can just remove this one, right? So I can put in my own value. Yeah, that's more fun. This one here. So we're looking for 3220 D9. That's probably too short. Yeah, we have that multiple times. D9 7718 DA. Okay, that's only once, and then we need to remove 3220 D9, right? And then we will load a. So we're gonna remove this one, and then we will apply the hacked ROM. And I think so. D920 was the color, right? It's on 9 now. Let's see if I can. So this timer is going to count, but this isn't going to update anymore. It's not going to take the bottom 4 bits into this thing. And indeed, this one becomes gray. So if I now change that to 4, it becomes blue. Yes. Okay. And apparently there's 2 different counters for because this one still flickers, right? So I don't know why that's the case. Yeah, the color or the... I don't know where that is set, because that should change too. Right. Okay, so this is D920 password screen. How I'm gonna name that though. Password selection box border color. And then I'm going to include D91C in it. Border box, selection box border color timer, which is D91C. For bottom bits of this timer is copied into D920 and used as border color. Okay. It's a bit weird that we don't see the other color here. Like that must be flickering somewhere too. It's not these guys. That's a debounce timer, okay. Like why would that not be the case here? Why would that not be present? And it is normal, right? It is actually moving that color. Weird. Okay, let's reset that. I'm gonna save this state. Wait, no, let me save this state as hack password selection. And then I'm going to reset with the regular, well, no, I'm gonna load the regular ROM this way. No, that's hacked as well. I'm going to get a regular ROM loaded, and I'm going to reset, going to the password thing so I can jump there too. Okay, let's save this one as well. Right, so this is counting again. So strangely, this adds up. Okay, no, I want to go backspace. I don't know what that is though, NG. If I press up and down, I don't remember what that means, but I can't go backspace anymore. Can I go with the keyboard? I cannot. Okay. Oh, and it's okay, sure. It loads level 1 if you don't have a correct password, of course. Yeah, I don't know what the NG means. And I doubt I can find that on the internet, because who knows, right? But yeah, this adds up depending, so this becomes 48. So regardless of what you pick, this adds a certain number until 88, and then we're in this state where we can't go back. I mean, I can't choose between 1 and NG, which changes nothing in the memory section here, at least. Oh, is that like no-go, like go back? Because it's, okay, sure. It might change when I put an actual correct password in there, perhaps. I'm not really sure if that is the case. But yeah, so this number adds up, right? When I add inputs. I mean, this looks to be also X and Y, right? So we start at 3, 6 for some reason, and these guys do. No, that's weird. So we have to figure out what, I mean, okay, it was up there, I think. Yeah. Okay, so over here we see selection. So I think this might be the amount, perhaps. Wait, does that change? Yes, that does change. So we have 1, 2, 3 appearing here, and so D8, D9, I think those are tile IDs, right? 216, let's go see. What did I say? 216. Yeah, that's Lala facing right. Yeah, so that's definitely, I mean, we have D8, 9, 10, and 11. That's indeed the 4 tiles of Lala. So this is the last selected, or the previous entered sprite. And then we have 1, 2, 3. Why that would be different variables or addresses here, bytes here, that surprises me. Oh, and then 13. Okay. Oh, are these actually the selected things? Okay. Wait. Right. So if I go this, it becomes 22, 21. Okay, sure. And Lolo is 1. So we do have our selected. This is our password that we selected, right? Meaning we start from 1 here and we go all the way to 22 hex. Oops. Which is, of course, 2 times 16 and 2 is 34. Do we have 34? Well, no, because, wait, 1, 2, 3, 4, 5, 6, 7. So 4, 7 is 28. And 6 is 34. Yeah, we have 34 options. And it's simply the index. Okay. And if I select the last one, then that becomes okay, so we have 5 slots for that. Okay, D85A. Okay, they spread that around. What's in between here? Current map data power up. Why is that so spread out? Like clearly password screen stuff is right here, and then we're putting the passwords, selected password values here. That's unfortunate. D85A. Okay, so we have 5 options here. We have 5 positions. That's these 5. And those are just an index from 1 to hex, well, 34. Top left to bottom, well, top to left to right, top to bottom. Okay. So that's where we put the passwords, and then these guys are the previously selected. Why would we need the previously selected tiles? Because B4 is 180, and that's going to be the front-facing goal, I think. Right, so B4 was 180. That should be... That's this one, yeah, that's the front-facing goal. Yes, which we probably also fix in the same way as we fixed before. But why would we need that? Like, unless we're pushing that into somewhere else, because we still have to visualize these. Well, we can copy this into some sort of map. We have to store it somewhere though. Wait, did it appear here perhaps? So, no, right? These guys don't appear here. No. So yeah, NG is cancelled. That's cool. So I mean, this one follows, when I press space, this one follows, that's the index that's currently selected, but it doesn't change with moving the thing. It's only when I activate, like it's a placeholder, I guess. So yeah, D855. So this is password screen. I mean, I'm gonna call this placeholder for selected index, only updated when selecting a sprite. And then we have the same with the 4 tiles, right? Selected tile 1 to 4, which is 6. Okay. So that's these guys. I mean, it doesn't, it's only like acts on spacebar, because that's when these values are copied, and then they're probably copied somewhere else. But there is another section in memory where this stuff is handled, because we have to have a similar timer. Like, that doesn't make sense otherwise. Yeah, we had to look at this one too. So we had an XY coordinate here, but we have a similar one over here, I think. So this looks to be, no, it's these guys. This one, that's a Y, and that's an X next to it. But why it's these big numbers? That's a bit weird. I mean, I'm gonna put big here, and then we have small before that, and it's at, which ones were they? Oh no, over here, these guys, I guess. Yeah, so D915. Is Y and X, but small. Okay, and then this one we haven't seen change, right? Does it change? No. I'm going to put in a password that is correct though. See if that changes anything. Okay, so we have up arrow. I don't know what the... Okay, no, wait. There's a different site that has the actual pictures of the... Yeah. This is what I want. So stage 6 is up arrow, heart framer, snaky front right, block, and then the last one is this one. And let's see. Okay, so it immediately updated to 6. I mean, it's perhaps this one here as the calculated round number. If that's changing, we'll have to change. I'll have to look, right? No. Unless that gets... Okay, let me put another one in, 56 here, to see if this 6 changes. Because I didn't see anything change. Yes, absolutely. 38 should be 56, right? So 38 is 56, that's correct. So 38, that is D866. Is password screen. I think it's standard 6 because it's the first, perhaps. Although if it's wrong, we jump to 1, right? So and this doesn't change, so unless I put in a wrong password. Yeah, then it changes to 1. Okay. So if I now do indeed like 88, it should jump to... Okay, then it's just visualization. Okay, wait. This might be a calculated value and doesn't necessarily mean the round we actually jump to. Yeah, so if I change this... Oh no, it does... Well... No, it doesn't update visually, so it's not bad. But we also don't jump to 44 then. That's interesting. Okay, D866, I did password screen, round number, changes based on password being correct. Okay. Okay, so see if I can find some more of these fast-moving timers, unless it's this one, but I doubt it though. Because there might be other information next to that one. And I think we're too high here already. Yeah, these are functions. Yeah, that's music stuff. I mean, this looks like data though. Don't know what that is. Like nothing moving here. Like only these ones are moving. And then the ones we already have. And then we were into basic, right? Below here. I mean, it's not going to be this. Yeah, this is basic stuff, I think. Well, we do have some timers here, though. They don't seem to be affected. Oh, we're at the very end here. Okay. Wait, what's weird is this one now also... I thought this one counted up all the way to FF. Why is that not the case? Because now it does do the same thing, though. As in, only the 4 bottom bits are retained. So it might be actually... I mean, it goes too quick, of course. So D91C we looked at, and that got written to here. Yeah, that was the border color of the bottom one. And HL is a pointer which we load here. So we're loading 0 in what HL points to, but that, yeah, and then we put our pointer to our function here, to this one. And I know it's the timer. Okay, yeah, we take the timer, we load the value of that into an accumulator, we increase it, we take the 4 bottom bits, and we write it to the... Oh, wait, we're writing the accumulator into the border color variable, which is this one, and then also into what HL points to, which is still the timer. Meaning if we knock out this one, then we will disable this one as well. Yeah. So now, okay. I don't know why they would have two variable, like two different counters, or like color counters, because I mean they're in sync anyway. Why would you do that? So well, let's remove this one too. I think I still have it open. Yeah, it's this 77 here that we have to remove as well. Right. And if we now go to our hacked password selection, that should be... Yeah, so now they both don't move. So it is indeed, one is for the top box, and this one is for the bottom box. So I'm going to make them both blue by changing everything to 4. Yeah, okay. So that's indeed, so this is not a timer in the sense that, well, it updates one, but it's, and then it copies it to the second one. I don't know why they have 2 different variables for that. That doesn't seem that efficient or whatever, like why. So this is top box. Okay, so they were indeed there. I mean, nothing else moved, so it does make sense. Okay, so I mean, they don't move, but that's fine. Oh, this changes too. weird that like it gets 16 gets added to that every time. So it starts at 38, 48, 5, 6, 7, 88, and that's... And our timer stops then, right? That's also... Wait, let's load the normal one. So because our timers have to stop or become 0 when we have 5 entries. So when this becomes 88, they stop. Okay, let's look at writing of this variable. So we see what happens when we, because this function will validate the entered sprites that we picked and calculate the corresponding round we have to jump to. That function isn't going to actually do the jumping, of course. That's the next spacebar. So we have to find that too, but then at least we can see where the passwords are located, either in the ROM or in the hard-coded in the code. Wait, so I have to be in the correct, I'm in the correct ROM, and I need to write something here. Watch D866. For writing. Okay, so it doesn't get written. I mean, it only gets written now, right? When I select the next one, yeah. Okay, it loads 1 into. So this is the you're wrong kind of thing, right? Because the password is incorrect, so we're loading 1 into the round number. And we are returning here. Okay, so where does this function start? I can jump out of this one though, because this does lots of passwords related stuff. So yeah, let's jump out this function because it does a lot of things passwords related. Perhaps starts around here. Yeah, perhaps here. Okay, let's see. We are broken in this function. Let's jump out of this one. Oh, and it doesn't. Oh, crap. Okay, let's do that again. Wait, are we? Okay. Okay, it's super slow for some reason. Yeah, it wasn't updating. Okay. And seeing if I can. Wait, what? That's not where I was. Again. So I'm at AD8F. Oh, it's jumping. Okay, okay, sure. ADA5 is where we are jumping to. ADA5 over here. Okay, calling 69 here. That's a BIOS call. Initialize all sprites. Okay, so we're calling a couple functions. Do we return? Nope. We're loading the screen, the round number. I think this might be a good place to jump to though. Well, I mean, in this password's related though. Yeah, so we're loading the round number into the accumulator, loading it into C. loading the current level into HL. Okay. So that's 1, right? Because we're jumping to 1, we're loading current level into HL. That's the address of current level. Okay, so that's a pointer. And then we're calling 6C48. Oh, right. So we are not yet, we haven't pressed space yet. D5. Oh, return the joystick status. Okay. And we return, so we get the joystick status. So I can't jump out of this. I mean, I guess we're in a Niflet loop here too, but I want to see what happens before though. Okay, so we're waiting on an input here. Okay. Okay, so this is probably also a spacebar check or something. Yeah, because we're waiting on an input, right? That does make sense. So I can't really see what, I can't jump out of this thing here. I need to get higher in this function. So yeah, we're loading 1 here, but I need to know. Oh yeah, no, let me enter a correct password. Simple as that, of course. Yeah. Then we will see where we end up. Okay. Now we end up somewhere else. Okay, we're looping here. 80, 60, that's here. Sure. So our value is in C because we're loading C into A, and an A gets put into both password screen round number and current level. Yeah, there's quite a bit happening here. That's true. Welcome, by the way. It is a bit complex, but yeah, I mean, that's reverse engineering, right? So that's part of it. So yeah, C has our value here, but we could have jumped here somewhere. So yeah, oh no, C is 6 here. So for sure, this is the detection of this specific password. And we're doing something, okay, right. So we're loading 6 in C, which is our target level number, round number. We're doing something 5 times, like we're pushing 5 into B. That B is always our loop iteration thing. Okay, what are you studying? So we have 5 iterations, meaning 1, 2, 3, 4, 5 blocks, right? That makes sense. And then we check, okay, we get the base pointer of the first sprite. Screen selected sprite. Yeah, that's these guys, these 5 guys here. And then we're adding the value of DE to the accumulator, which we're going to load with that's weird because, well, no, I mean, I'm down here now, right? 6 is in the accumulator. Okay, so I'm assuming, wait, let me go here. Let's restart this stuff. Okay, now I have to get the entire password again. Okay. So now we're loading 6 here. The accumulator has 1 in it. I don't know. Oh yeah, wait. We're comparing something to 1 here. Okay, so we have determined already that we have to jump to level 6. Oh, that's fun. I wish you the best of luck. So yeah, at this point we know that we're going to have to go to level 6. So we've already done the password validation. We're just doing something here. And then at the end, we will write 6 into our level numbers, both for this password screen and the current level, which we're going to jump to then. Okay, so we're pushing HL, that's fine. We're loading 5, that's the iteration count. So we're looping all the password entries. So we're getting the base pointer to the first thing here, that's D85A, which is in DE. We're loading the value, we're loading the value of DE into the accumulator, which is going to be 1D, right? That's going to be the up arrow here. Right, 1D, and we're comparing it with the value of HL BO4A. Okay, wait. BO4A. This is a comparison of passwords. BO4A, which is deep in the ROM, makes sense. BO4A. Okay, and it is 1D. So why would it do the check again after already having determined it's 6? I'm gonna do it with a different password in a moment to see if we end up in the same spot. Because it might be even... We might simply have to add something n times to 6 to get to the next levels. Because if you look at the bonus stages, so yeah, you start at 6, but the next one is 5 more than that, right? And then again, 5 more. So we're looping probably all the passwords. Well, let's see. Yeah, so we're comparing this to this, and I have to get another memory thing open here so I can compare better, right? So we are at, I'm going to put BO40 in this one here, right? That's this one, and I'm going to go back to my main memory here. Where were we? Yeah, so these are our 5 passwords, 1D070B. Yeah, that is exactly this. Okay, we can give that a name. 60. Okay, wait. Why are these here? Oh yeah, that was also in the ROM. Sure. And then we're in between here. So BO4A. This is level 6, I guess. Well, yeah, right. So this password stage 6. I guess round 6. And this is sprite 1. Five. Okay, so we have this A, B, C, D, and E. So that's the password for the first for round 6, right? The first password. Right, that's these 5 guys. Now I wonder if this is going to be sequential. I mean, it literally says special word, password, round, like it literally has a text right above it, so it does make sense that it's in this area. 1E. I mean, okay, let's just put in the next passwords to see if it's if it makes sense, right? Disable you, continue. We do have breakpoint here. That's fine. I'm gonna cancel that and put in the next password, which is down, low right, open activated skull, snaky left, and exit closed. Okay, what do we have now? We have 1E. Let me see my memory. 1E01, 1B 0905. Yeah, they're sequentially like one after the other. That's fine. Okay, so it's gonna take some time to copy all of these, but that's fine. So how many do we have? For 100 levels, that's what is that? 2, 4, 6, 8, 10, 20 passwords. 20 times 5, of course, is 100. That makes sense. So we have 20 passwords. I mean, sure. Okay, 61, 2. I need to make this in JSON though, so I have a better, like I have to create this information in JSON and then write a converter so I don't have to type out all this stuff. That's a bit silly. Because I can easily make mistakes by skipping one, and I have to look around for half an hour to find out where I made a mistake, and that's not ideal. Hi Hezrin, how are you? Well, it's progressing nicely. I'm taking a look at the storage of the passwords in the ROM, and we seem to have figured out quite a bit already, so that's quite nice. But yeah, I'm still looking for a function or some code to jump to a specific round. So that's a bit of the target now, but we'll see what we can do. I'm not sure I'm gonna be able to find a variable that does exactly that. That actually triggers the jumping, but I mean, we'll have to write some code then, that's fine. 56, C, D, E, F, 80. And then 61, 3, 4, 5. Where are we? 61 becomes 66. 6, 7, 8, 9, A. I mean, I might have already made a mistake, so probably have to go redo an entire batch of these. A, that's B, C, D, E, F. Then we have 76. Oops. 0. Oops. Okay. 1, 2, 3, 4. We have 81. Okay. 5, 6, 7, 8, 9. We have 86. A, B, C, D, E. 91. E, F. A, I guess, and then 0, 1, 2, 3. That's correct, right? 9F, A, 0. And then the second to last one is 9, 6. 4, 5, 6, 7, 8. And then the final one, I mean, not the final one, because there's a special password as well, which might be after this. 9A, B, C, D. And let's see how that looks. Hopefully I didn't make a mistake. It doesn't look like. So yeah, we have our passwords, and we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I mean, you don't know where it stops, of course. I'm gonna, well, I can't really enter that one. Could I? Because we've already made a determination as to which round we have to take. I mean, I can put them in here, but I doubt it will work, though. Although, I mean, we can try, though. So if we go look at our breakpoint again, that's over here. This one actually goes to look into this section of memory, right? So yeah, we're comparing stuff here, and we're increasing HL. So I'm going to do that again, and I'm going to put in a bogus password. I'm going to keep this to the side here, and we are running. I'm going to clear, and I'm going to put an incorrect password. And I'm going to try, first of all, to force in a correct password in our selection here. So 1D070BOE1F, and see if it still puts us in level 6. I mean, it already put round 1 here though, so I doubt, but sure. So yeah, we're comparing, we're doing this 5 times, this little loop 5 times to see whether the password is correct. We're at 2, 1, and then 0. Okay, so we're out of this. The accumulator is 1F. That, oh no, C is, yeah, okay. So C is now 6. We're going to copy 6 into the accumulator and put that in our level round number. So this is going to get me to level 6. Yes. So now we have a fake password and a correct answer. Question is, if I put the second password in, so it did 5 loops, right? And it compared it to the first 5 bytes here. Where is my increment to, like, it has to do this 20 times though, like, why is this just the check for level around 6? That's a bit weird. Because C never changes. Like, where's the rest though? I mean, I guess it's elsewhere, but because if I now wait here, I'm going to clear, I'm going to put in an incorrect password. I'm going to overwrite it with the second password, which is round 11 sprite 1 is 1E011B0905. Yeah, that's this one, right? So 1E011B0905. Yeah, so that's the password for the second, well, the second password. which should get me to around 12, right? Or what is it? No, right, around 11. So question is, does it do that now? So we get the pointer to this one here. Okay, sure. Okay, 1E comparing to the value of HL point, still pointing to B04A. So no, this straight points to the first one. So it's gonna fail. It's gonna put me on level 1. It's already jumping. Yeah, so it detected an incorrect entry and it jumps out. Okay, that's like, this is validation of the first of the literally only of the password for level 6. It's so weird why that would be separated out. And I don't see the rest here. Like, where's the rest? Okay, let's try. Should I give this a name? I don't think this is jumped to though. 85.0. Yeah, no, I am going to, I'm going to give this a name, this loop. Well, I mean the 6, right? The 6 is the round number. So I'm gonna, even though it's not really a function that's being jumped to, I'm going to add it anyway. OXAD. Okay, we have one thing with OXA, sure. So this is validate password for round 6 is at OXAD58. Right. Even though it's not really a function that's being jumped to, we still can add this as a comment, right? So now I'm going to put the right watch point again for our level number and add the password for the next password. To see, I mean, it shouldn't jump here. It should jump somewhere else where we're doing the same check, but with a different pointer to a different password. That's what surprises me, that you're doing the same routine. The only thing that changes is the pointer to the correct password and the round number you have to jump to. So that's a bit weird, like that's a waste of space. Okay, so clear, and then put in the correct password for level 2 here, or for 11, I guess. Down, Lolo, right, open skull, snaky left, and closed door. Of course, you do have to put on the breakpoint for it to work. Again, down, Lolo, right, open skull, snaky left, and closed door. Okay, so we're stopping somewhere else now, I'm assuming. Yep. And this is, oh wait, so we're jumping to 11, right? Was it, yeah, it was level 11. That is B, right? Yeah, 10 is A, 11 is B. Then we have B here. Wait, that's great. Okay, okay, but we could have jumped from somewhere higher up though, which is unfortunate because we can't go back for some, I mean, I don't know where we're coming from, right? Because we're in the exact same area here. I mean, it's the exact same one that puts 6 in here, only we've jumped over. So that's why I assumed it's up here somewhere, but I don't see a load of OB, was it? Yeah, it was 11 OB into the C register, unless I'm looking over it, but Where's my second? Oh, behind here. Okay, this guy. So we're not near our passwords here, right? Well, I mean, they are, well, no, they're quite a bit down. Like, it's unfortunate I can't go back here and see where we were jumping from, because we must have jumped from somewhere to here, though. Skipping, well, I mean, I guess we would have to jump here then, right? Because we don't want to load 6 in this thing. But we do want to do the loop, because this loop simply loops all the, even though, no, because it still points to the first password, though. Wait, no. Wait, no. This loads the thing I entered. It's comparing with the value of HL, so HL is pointing to the thing, yeah. Also, did we break? Yeah, wait, so the accumulator has OB in it, which is our target level, right? Okay, let me reactivate this one and see whether that happens for this password as well. It does. Crazy. Oh, and HL was our target password, which is BO4A, which is the first password. Okay, so fine. So we're loading 6 in there. We're pushing our HL to our on the stack, that's fine. We're loading 5 because we have 5 passwords to check, 5 sprites to check. We're loading our first one and the value in the accumulator, fine. We're comparing it what the HL points to. If it doesn't match, we bail, but it. Oh right, and here we iterate. Okay, makes sense. I think because we will jump back up. I think. Yeah. So okay, we're popping HL again, and we're going to increment. Yep, exactly what we're doing. So we're loading 5 into the E. We're going to add 5 to our pointer to the first password. Makes sense. Makes absolute sense. And then HL will be pointing at BO4F. So now we're pointing to BO4A. We're loading 5. We're adding them together. We're pointing to BO4F now. And we're loading C into A. C being 6. That's... Oh, and we're adding 5. Absolutely makes sense. So this checks all the... And we're stopping at 65, meaning 101. I mean, it's going to, like... It's like a max check, like a max bound, upper bound check. Yeah, we stop at 100. So that's not the case. We're loading A into C, which is 6 plus 5, right? We're checking whether it's 0. Why would we do that though? We're subtracting 65, which is 101. And we're back here where we are. Okay. Okay, so this does loop all the passwords. I guess the start of this little function is this this one though. I need to be able to add comments to this. I need to add a column for comments so I can like write this stuff down, because otherwise I'm gonna forget. But yeah, so this first loop compares the password with the current password pointer, and then afterwards we increment the pointer, check whether it's under 100, and add 5 to our destination round number. Yeah. And then if we do have a match, we write that in our level numbers, and then we call something. I don't know if we looked at what this function does, because this might jump away and actually start the level. Well, no, we're not starting the level. We are, because we still have to confirm. We have to fill in this sprite, and then the next space will actually run the level. Yeah, so it's not round 6. It's validate passwords. I mean, yeah, let me put it one below, because then that way that function is seen here as well. And this one is a failure point where we jump to if the password is incorrect. I think AD8A, is that correct? No, so it's AD76 that we jump to. Oh yeah, we have to try all the passwords, of course. So we do jump. So AD76 is move to next password. Like, yeah. Point to next password for check. And then, yeah, we're comparing to 101, and then 88.4 is where we jump if that's the case. Oh, wait. Yeah, I think I see what's happening here. Yeah, the last difference is 4. That makes sense too. So we're starting at 6, we're adding 5 every time, but of course the 96 would end up with 101, so we're truncating at 100. That's what that is, right? Because we are checking here, we're comparing with 65 after we have added 5 to our current level number, which would make it 101, which is hex 65. If that's the case, we load 64 into the accumulator, as in we truncate to 100, right? And then we validate again the password. Now I don't see how we escape here though. So JR885. So this is if we have a password match. We call, did I look at AFCE? Oh yeah, that was the next iteration, right? AFCE. Wait, no. AFCE 1995. That's the pointer, okay. We're loading the current level into the accumulator. We're comparing with FF, meaning -1 perhaps. And we're doing an unconditional jump here. That's a bit weird. I'm doing both, but yeah, the end goal would be to like re-implement, and for that I needed to know the exact movements of the AI of the mobs, right? Because they move in a very specific way, and I would like to re-implement it exactly how it was in 1985 with the same timing, because these puzzles, if you look at these puzzles, they have to be timed a certain way Like it has to be correct. That's why I'm and of course it's fun to like figure out how everything works, because I don't really need to reverse engineer the password system to re-implement it. Like that's not a big deal. Like all these passwords are known. I don't need to find out, even though I found them here. Here are the passwords. I don't really need that because the information is right here, of course. But I mean, it is still fun to figure out how they did stuff. Yeah. Now the hard part is going to be figuring out, because over here not for the movement of the mobs, no, because I think like there's an enemy, and that's in Eggerland 2 though, that throws a dagger at you, and you have, so the movement speed of Lolo, the main character, and the dagger speed have to be the exact same, because if you don't do that, if it's faster or slower, it might affect the solution of the level. So some things are like not timed, but tracked, like solvable based on how fast things move. So that's why I think it's best to like do it the exact same. Hello, Alberta. How are you? Yeah, so it's I'm doing well. So yeah, that makes it a bit, it has to be exact. Yeah. Now we can't rely on this current level being set either, because it happens right after we change this number here, which is unfortunate, because that would have been a good thing to look at when we actually go in the level, because I don't think, wait, let me check C81B. Yeah, so we have current level and current bonus level and level timer, but we don't, like, we immediately change this after continuing here. I'm gonna remove the watch point. My day has been fine, quite productive actually, so I'm happy. Yeah, so we changed around here and immediately it gets set to the actual value here as well, meaning we can't, like if I press space now, I can't check anything because it's already set to 11 here. So I do need a input detection. I mean, I guess I can check. Yeah, it's this one, I guess, that gets set. I don't know why. I'm still doing more of the same, as in looking inside Eggerland. I was just looking at how the password system worked, which is quite interesting, because we did find the storage of all the passwords of all the levels inside the ROM here. That was fun. Oh, and I did want to check whether this was the bonus password for the special level. Yeah, this one here. Oh, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right, this is longer. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Probably that one. So I don't know what these numbers, well, no, they were indexes, right? Right. So if you go back to the game, to the password selection thing, OE is 10, well, that's 13, I guess. Yeah, 14, 15, yeah, 13 would be 7, 8, 9, 10, 11, 12, 13. Is it this one? That's D. I need OE is the next one. Okay, it's the block. Yeah, it's the block. And the block, so the block is OE. The first one here is OE. Oh, that's fine, my pleasure. OE is the block, and that is the first one of the super password here, the special word. Yeah. So this is special word 10 things here. So let's add those two. BOAE. Which is after this, of course. Yeah. Oh, there's 10, of course. EF, that becomes P. 6, 7, 8, 9, 10. Yeah, here the special word is now set as well. Don't know what these guys are. If it might not be related to passwords. I mean, it is data though. It is static data, for sure. But yeah, not really sure what it is. So yeah, we found that too. And the heart would be 21, which was the last one, or yeah, that 22 was the last one. Yeah, so that's for sure correct. But yeah, finding a trigger is much harder, of course. Oh, and I can't even enter that. Oh yeah, I don't enter that password here. Right. That's a different location. So you have to play level 100 for that. Right. So let's see. I mean, I haven't played level 100 in a very long time, and I don't know what it looks like. Okay, we broke, but that's fine. I'm gonna save this level. How to solve this one? I mean, I can cheat, of course. Yeah, I think I'm gonna have to cheat because I don't know how to solve. I mean, you take the top right one. I mean, this one is where you have to be quick though. I mean, I can try it once. Let's see what happens. You have to wait for the skull to be in a certain spot to avoid the Medusa. Oh, wait, no, I had to do that. Did I not? Wait, I'm already... Okay, that's already wrong. Yeah, because I have to use the snaky to float on the water. That's, okay. Back in 1995, I would have been very mad because I didn't have save states. But yeah, I have to avoid blocking the bridge over there, I think. So I think I have to use snaky here. Right, it won't hurt me now. Wait, but I do have to put the blocks somewhere. Where do I have to? Oh yeah, I have to... Okay, let me first get it and see what happens. Oh yeah, okay, I can't escape here, so I have to use... Okay, this is too complex. I need to cheat here because I don't remember how to solve this level. And we will do this like this. Oh no, hard framers left is D1F2. If we put this on 0, the door should open. Yeah. Okay, and now, wait. Oh, this is a bonus level. Okay, sure. Bonus 20 is after level 100. But yeah, we don't need to play this one. C81D is the timer. C81D. Okay, 5 seconds left. That's fine. Okay, we have the special word number 10, and then here is a special word thing. That's the one I was looking for. Special word entry password screen. Okay, and then you have to have the correct password, of course. Okay, let's see what that changes. Does that change? No, that's down here with the other passwords, I assume. Yeah, in this section perhaps. Yeah, so we are using the same thing and probably the same password fields. Yes, we do use the same one, but these can go all the way to here then, because there's 10 entries here, right? Okay, it's probably gonna, yeah, of course, it immediately kicks you out. Wow. Okay, so these are, I'm gonna rename this, so password screen. Is it selected sprite that I call this? Well, it's not, I mean, and then we don't have 5, but we have 10. For the special word. Right, so we have all 10 now. I'm gonna have to enter it to see what happens, because it's immediately going to act on me entering the correct password. So I can't see any change here though. That's going to be difficult to break. Okay, let's see if we can see anything change. Yeah, no, not really. I didn't see anything change that easily. So yeah, now we're around 101. This didn't change to 101. Did our current level change to 65? Yes, it did. That did change. So I guess I could break on that. Yeah, I could break on that. So let's, well, I should have saved that state with the correct password, of course. Crap. Because now I have to put it in again. And I'm wrong already. And the last one is a heart, but that I have to remember then. What did I call this? Special word entry password screen. Special word entry before heart. Okay. And now I'm going to put in current level a watch point, C81B. And something is going to write 65 in there, and that will be our function that checks the special word. Yeah, so 65 is loaded into the current level, and in C807. Okay, C807. Oh, that's interesting. I never looked at that. What is this? That's the score. That's interesting. So C807 also contains the current level for some reason. We're calling clear screen a map. Okay. This might be the sequence to actually load a level then. We're loading something into the current level where, regardless of this one, and then we're clearing the screen and map. Perhaps what these two functions do. So we can perhaps jump here. Yeah, we can do a jump to 6193 after putting something in current level. That might be a good target if you want to implement a custom jump to round function. Because yeah, this is literally what it does, right? It sets the correct map number, round number, and it just clears the screen and goes. Oh, and it's quite a short function because we're jumping here unconditionally 412C. Yeah, so this is all we have to do. We have to do 3 things, and we jump to let's go. Is this the clear function? Render bullet count. Okay. Let's see if I can exit from this function. So yeah, 618b, I'm going to give a name even though it's not really a function. 618 I don't have. So yeah, that's indeed right above decrement HL. Load level 101. 618b. Well, I don't have to add that, that's fine. Just so I can jump to that, or I mean, let's call it round. I have to be more consistent with my naming here, calling it round and level and map and whatever, yeah. Can I escape from this function? Let's see, I doubt it though. Yeah, no, I cannot. I mean, I can see if we end up somewhere higher here after doing this. If we enter the correct thing here. Okay, so this is the first we jump to. So these guys are not applicable unless it's higher up. That jumps here, 6188. Yeah, I don't immediately see a jump to 6188. It would be handy if I could search in this stuff though. Based on C. Wait, what? I have to look this one up. So I'm not saying something stupid here. So jump C and I guess, yeah. If the carry flag is set, and so we're jumping if the carry flag is set. Which it isn't, so we do not jump to 409F. Wait, so let's jump and see what it does. Can I, wait, no, yeah, I can. Okay, so does this get us to the main menu now? Yes, it does. So that's the failure state. So why are we not here though in these functions? Are we jumping? Yeah, I wonder why it's not breaking here when we input. Oh, but we input the correct password though. So maybe we do break here if it's the incorrect password. I'm just trying to see where the function starts, right? If I can do that, that would give me some more information. So I'm gonna put in the wrong password. Still over here, and the stack doesn't contain any good information either. And I don't think we can jump out of where we were either. So, well, now we're definitely gonna jump, right? So, yeah, no. Yeah, I need to be able to search here. I want to search for a jump to 6188. That should give me like the starting point, right? Where we are validating the password. I mean, I can put watch points on other locations, of course. For example, the ones that read the password itself, right? These guys here, these 10 numbers, like they have to be checked. So I can find that, of course. Actually, I'm gonna put that one higher because that's where it broke first, right? So I think the jump might actually be to 8.8 instead of 8B. So here, because that checks the carry flag and we never break here. So I think we jump here. Now let's put a watch point on the password when we enter the secret word, special word. So these are all set now. We have to do the last one. I'm gonna put one on this one, D85A. So a read watch point on the first password character. Did we break already? Crap, that wouldn't be good. Okay, no, it's fine. So I'm going to put in the correct password. And here are we reading? Okay. So we're in the same routine here, the same validate password stuff. Wait, does that make sense? Because they are sequentially after each other. So basically it's just checking 2 sets of 5 passwords, right? So that doesn't make it that much different than the other ones. Okay, so we're comparing with HL, right? So we are in a tight loop here, or are we not? No. This was our tight loop for checking passwords. So this one had 5 iterations of the DJ and Z, which is the for loop, right? We're doing this 5 times. Do we do this 10 times here? Wait, do we have a jump? Yes, we have a jump. 8099. AD99, that's here. Yeah, of course, here is 10. Yeah. So this is check the special word. Okay. I think it starts here. So we're loading HL to special word, of course. Yes. 89.1. Validate special word. Yeah, because we're loading the special word into HL and the entered password into DE. We're doing something 10 times and we're comparing, checking whether it's correct. We're incrementing both, of course. We're we're progressing through the password. Yeah. And then we're checking. Oh, right. And we're checking and we are returning here. And then our carry flag will be verified because the AND is either going to set or unset the carry flag based on our well, yeah, because wait, we're in DE and A. If it's wrong, we jump to 88.3. That's down here. Okay, SC, I don't know what SCF is. Let's look. Oh, set the carry flag, of course. So it sets, wait, 88.3. Oh, this, okay, so the carry flag isn't set by the AND, it's just checks whether it's 0 for some reason and returns carry flag not being set. And this one, if it fails, it is set and we return. So that means that we are returning from a call though. That's interesting because that will return us to the function where we came from. Okay, so we have to do this 10 times. 7, 6, 5, 4, 3, 2, 1. And now it's going to be 0 and we continue. So we check, well, A is 21 for some reason, but that's fine, I guess. And we return without setting the carry flag, so the password was correct. Otherwise, we would have jumped here and we would have set the carry flag. So now let's see where we end up. Okay. We are jumping to 409F if the carry flag is set, meaning 409F is show main menu. I have to give that a name too though. 409F has to be show main menu. Yeah, even though I do have a show menu. 40AF, I'm gonna duplicate this because I mean, I'm not sure about this. 409F. So we have to see what's different between these two. If the carry flag is set, we jump. So this call was AC67, right? That was the password validation function. AC67 is here. Okay, so this is the validate passwords function. Like, well, AC67, and we end up, I guess, here with our little routines. Yeah, validate passwords. So the start of that function is AC67, was it? I don't know what all it is doing though, but and we're referencing memory values and stuff that we don't know yet. I'm gonna put AC67 in a thing here, and this is a 5 sprite password. Validate 5 sprite passwords, validate special word, and then we have validate password equals AC67. So that means that if we go where we are. Yeah. So we call validate password here. We must have, this must be a input detection function, as in acting upon a spacebar click. I don't know where this function starts though, because this does have nothing to do with also. So this is the routine for the special word, right? It loads 1 into the accumulator. In other words, validate password's first argument is true, which might be for the special word. So we'll have to see if the same function is called for the regular passwords and if it's false or whatever, right? Okay, so we're putting 101 in the current level and in C807. Let's look at the first, at a normal password to see if it calls this the same function, which is validate password. I do want to put a breakpoint on that though. Validate password is up here. Yeah, so that's probably not the start of that function. Let's reset. It doesn't jump there. C8D, that's too low. It has to be AC something, right? That's unfortunate. AFP9. No, it's AD. It has to be AD. That's too low. And we don't have any returns here either, right? We are not returning here. AD50. I mean, it must be something specifically for the special word then. That's unfortunate. Wait. Okay, this one doesn't jump there either then. Okay, wait. That doesn't make sense. I have to get back where that was called though. I mean, it wasn't called, that's the entire problem. So was it this one, D866? Let's see. Nope. So I needed to check on the current level number, I think C81B. Oh, I don't know why I did that, because The function does start here though. Yeah, we're jumping based on the carry flag. I don't know why I did that. Because that doesn't have anything to do with that. Wait, am I certain here? Yeah, why did I do that? I mean, it's near, but it's not. It has something to do with password stuff. But yeah, no. This is not validate password at all. This is validate passwords, and that's validate special word. So that's correct. But yeah, no. This is irrelevant. The function starts here. Okay. So we are loading the same number in C807, which was interesting. This is this one. And I don't remember if that's for specifically for the rounds 101 to 105, or if it's for all the numbers, for all the rounds. So let's look at that. Let's continue. So yeah, 6.5. I mean, these are hard levels though. Like I have to, that's why I need cheats, because I'm not gonna solve this. Like, okay. I mean, I guess I have to pick up the hearts and shoot. Okay, I don't need cheats, so never mind. Let's go to normal level and see whether this value gets set to the regular level number as well, and it does not. Okay. Okay, I'm gonna put that on 65. Wait, let me go before the exit here. Level 1 before exit. I'm gonna put 65 here. And exit. Wait, what? It changed it to 6. Oh, wait. No, it didn't affect this. So it is something to do with the special levels. So I'm going to go to level 102 by going. So my save state. Oh no, it's this one. This is a score. No, of course. Wait, did I put it in the correct one? No, I can't remember. No, I probably didn't, right? Okay, so that doesn't matter. Okay. I'm going to go to level 102 by putting the current level at 101. So we should be going to 102 now and see if that becomes 66 as well. And it does not. Oh, is that the round number? Okay, wait. Is that the round number that's visualized on the password selection screen? No, it says 1 or 0, and it is 1 here. Let me enter a valid password. No, so it doesn't update. It's not this number that's visualized. And it's not updated here either. It's only when I enter the special word. So let us put a watch point on that one. I'm gonna load this one and see where this gets read. We know where it gets written. It gets written like immediately when we enter the heart, but I want to see where it is read. C807 to see if something is done with that. immediately broken, but I'm gonna continue. That's fine. C807. I mean, it's written and there's nothing done with that. Okay, let me give myself some ammo here so I can kill these guys. Oh, I need a power up. Okay. Why does it not let me put a bridge here? Of course, I die. Yeah, why is this number not... Okay, I mean, I have to cheat in a different... Oh, wait. It is broken though. Right. Let's see. Where are we? Okay, I'm lost my space here. Is it here? Yeah, it is here. So it's on 65 now. And it's red when I die. So is this checking where I have to return? Yeah, of course, it's loaded here. We're checking whether it's 0, 6193. Okay. Okay, so this checks whether this this value is 0. If it is, it probably returns to level 1. Okay, so let's let it run. Does this happen? Okay, does this happen in regular levels as well? So I'm gonna go to level 2 before last heart framer, and I'm gonna have it kill me. I mean, it is 0 now though. So, okay, so this value isn't checked now. So that code isn't executed. So it only happens, it's like a death check in the 5 last levels. Can I immediately load 101? Yeah, 100. I have 100 here. No, I need 101. I didn't save that. So we have to go to this one and this one. And let's save that state as well. So if I put this on 0, I'm going to go to level 1 if I die here, I think. But I don't know why. Oh, it goes to the special word. Right. So this is... Oh, what was the rule again? No, this doesn't make sense. Like, this should never happen, though. Why would you need to see the special word screen after dying in level 101? Or wait, there was a rule. I mean, I have to check this again. So if the player successfully eliminates all enemies in the bonus levels, he's also awarded with a character or a 10-character special word. That's fine. The special word can only be entered after the completion of level 100. If it's entered incorrectly, you have to play level 100 again to have a chance to enter the word correctly. So you have to beat level 100 to see this screen. I forgot where that was. Of course, I have to put my right thing again, my right watch point. So let's load the state in the success state here and put a, well, it can be a right because it's right above it, right? So C807, that's fine. And I write here, I mean, the read was right here. C617D. I mean, I'm assuming this all belongs to this same function and we're not jumping here. So, I mean, we can make sure, of course, by breaking here. I mean, this has demo stuff in it. That's not, this looks like a reset function, right? Because we're writing 1.2 is demo mode, and that doesn't look like it belongs to what we're looking at. Active player is loaded. Like, I doubt. So I'm gonna add some extra breakpoints to see if we do end up a little bit higher here. And the trigger for that would be dying in the special word level, right? So I'm gonna remove the watch point. And I'm gonna die here. And now, okay, so we are in this function this high up. That's good. So perhaps it does have to reinitialize stuff. I mean, I might as well go higher up, right? Yeah, no, I can just die. Okay, interesting. I mean, here we see a return here somewhere, so we might be getting close here. Although, because we have a knob here, so maybe this is the first one. I don't see why we would have a knob in the middle of a function here, but you never know. This might be data though. Oh. Okay, let's die again. Crazy. So if we do go over that, oh, we jump over that, okay. But yeah, it calls her under bullet count, like what? Why would they do that here? And we do end up below here, right? So I'm jumping. I guess if this is the death function, that it resets everything, that's fine. So that could be the case. Yeah, because we do end up here in our check for C807. And it checks whether it's 0, and it is not 0. Oh, and then it jumps to immediately declare screen and map. I mean, sure, I can keep going up, that's fine. It is death related though, like, I mean, I guess. Oh yeah, yeah, it's the die function. Yeah, it is a die function. Sure. So the depth function does check this value then for some reason, and if it's 0, it immediately jumps to the clear screen and load, and if it's not, then it will so if it is 0, we jump to 6193, which is immediately clear screen and map. Otherwise, it will load 1 into A. Okay, wait. Oh, and an AC. Oh yeah, so it does the password check then, I guess, or something related to the password check, and then conditionally on that, it shows the main menu because of the carry flag. Sure, and then we load 65 in it. Bit weird. Like, why is that related to the def function? Where are we? Oh yeah, so these are irrelevant. It's going to be a die function, the def function here that we are going to trigger. I mean, I should have increased my lives here. What is it? 3. Where is my C811? Yeah, I thought it was here. So let's give us a bit more lives. Yeah, it's the die function. Okay, makes sense. Oh right, it's only a def. So let's play with that. I have to remove these here. Yeah, the def function does quite a bit though. Wow. Okay. I want to see what happens when I put something in there in a regular level, when there is a death, and well, I didn't need the lives. Okay. When I die in a regular level and there is a value in that here 65, and I die, what happens now? Nothing. Is my check even triggering here? So now we're breaking at that check, and now we're not breaking even. So yeah, there is a different check above that that prevents us from reaching this little thing here, this variable. It's weird though, like why it checks for 0. So I mean, I have to go through the die function though to figure out what is why we are not jumping all the way down there. So let's do that. Level 2 before exit, gonna put a value in here. We're gonna die and break in the die function. Okay, so we go through start level music. Also weird. Well, no, that's not start level music. That is a parameter of a piece of music we have to play. Okay, I have to sidetrack here and change that because I think 7 is the sound we have to play now. I have to turn on the music. Yeah, okay, so we'll come back to the die functions, and I'm going to disable these guys. Okay, so I heard the death sound. I'm going to go to the game loop because we have another start level music there. And I think that accumulator is going to have a different value. I think 7 is going to be the death music. Where's the game loop? Yeah, at the end here we start the level music, right? And it's 1. Okay, so if I change this to 7, I'm pretty sure that the main background music will become the death music. So I'm going to change that. That's a little sidetrack here, but that implies that the function name is different, as in it's just play music depending on the accumulator. So yeah, I copied that. I'm going to reload that here. And I'm going to find this one, 3E01 CDA9B6. And I'm going to change the 1 into 7, which is the death music. So now if we go apply our, or load the state, this one can kill me immediately. Yeah, it changed to 7. I was quick to see, but now we have, oh no, it doesn't matter. We just have to have a level. So yeah, start music now has, that's also interesting. I have start music and around, oh yeah, that's the trigger for the thing. Yeah, okay. Start level music now has 7 as a parameter. And I think if I start playing, I will hear the dead sound now. Yep, I do. And it only plays it once, so it's like a play routine. Okay, so start level music is play sound. Okay, and it gets sound ID. One is level background music. Okay, we can figure out the other ones too, but yeah, this is just a play sound function, not a level music. Okay, let's load the regular, yeah, I want a regular level, break on die, no music. So we died here, and now we're going to, oh yeah, so it plays sound 7. Okay, okay. We're loading current bonus level, checking whether that's 0. If it is, we jump, which we don't. I don't know how you can die in a bonus level though. Maybe from respawn, well no, because it doesn't respawn, the eggs I mean. Okay, so we're calling stuff, loading 89 into Lolo sprites. Okay, let's quickly check what 89 is. 98, sorry. That's 152. That could be, yeah, that's going to be the death thing, right? The death tiles. So 152 is going to be oh, that's weird. Okay, that's not a tile ID. Oh, it's a oh yeah, of course, it's a sprite, of course. 192 is going to be 152. 152. That's Lolo standing. Okay. That's just Lolo's. Oh yeah, because we wait, but we do have to do the death animation though. Maybe we do that later on. So oh yeah. So if he's facing right or left, we first face forward, which we're doing now, because we were walking down. But I'm assuming if we were walking left, we first have to face forward, and then we do the rotation when we die, right? Sure. We'll call something. Loading 3. Call something. XORing it with 5C. I mean, that becomes C4, and then that would be Yeah, so these updates, these are going to be video updates, which we don't see because we've broken now. But yeah, C4 is going to be probably be the def 196 is going to be the def one. Yeah. So sprite 196. Yeah, that's that def one. Yeah, and those are going to be rotated now. Okay, so this is the routine to draw the def sprites. Prep for VRAM, sure. So yeah, we're painting the def sprite. I think we're jumping a couple times, but that's fine. We are pointing somewhere with 6122, but that's a bit low, I guess. That's fine. Again with the sprites. Okay, we're looping again. I mean, we're still in the routine of doing this, the depth sprites, I think. I mean, it's hard to jump out of this because I don't know where it's going to go. Okay, is demo mode is checked? It's not the case. Get current player's lives address. Okay, loading that into. Okay, we're subtracting a live. Sure, we're writing that back into the value, into the memory value. Okay. We're loading 6 into accumulator. I don't know what that is. Demo recording, sure, is demo mode. Player lives, which now is 5. Okay, that's player 1 and 2, I think, that we're checking, ORing. Okay. Okay, now we're getting close. So we're loading current level into HL, the pointer at least, C81B, that's correct. That should be this one. Yes. We're loading the value into H, we're comparing to 65. Okay. Right. So that's why we're skipping over this, because it's 2, right? We're 11, 2, and we're comparing to 65. So this whole check for 807, which is what we're after, right? Like this variable here. This is now going to jump to 6193, which is go to, yeah, clear screen and map. So this function only gets, or this part gets only executed when we are in level 100 or more, or actually at 100. Oh wait, no, 101, 101. Okay, so this is the one we want, right? So yeah, it was going to jump over that. So if I die here again, we'll see that we do not hit this breakpoint, right? So I'm going to die here, and we are not hitting, yeah, we're hitting the die breakpoint. That's fine. We don't need that one anymore. And we are not hitting the breakpoint that we intended to. I'm going to, yeah, so after the jump. I'm going to force this so that it's true, and we'll see what happens. Well, I didn't need to do that, but okay, so current level is now 65. Yeah, okay, so now we are not going to jump. We are in our little function here. We check for bonus level, which is not the case. We check game mode, type A or B. We're checking whether it's A. And okay, if we jumped here, right? Yeah, we jumped to our check. So in game mode B, what do? We put 1 into what HL is pointing to. C81B is our level. Oh. I don't know what happens for type B in level 101 to 105 or 100 or something when you die. I don't know what that is. Okay, and now we're loading C807. It's 0, so we're gonna jump here, I think. Oh no, we're not jumping. Okay. So now we're loading 1 in A, and I'm not sure what this function does. Oh, was it show the password screen? Yes. Or a special word screen, right? So there is a condition where we die in level 100. And I mean, that is what this says, right? So if it's entered incorrectly, the player will have to beat the level 100 again to have a second chance to enter the word correctly. And I think that's what we're seeing though, but it has to do with death. So if you die in a certain circumstance, you go back to the special word screen. And it's dependent on this being 0. So let's redo that with 65 in it. So I'm going to go back to here, put 65 in our level and put 65 here. So we die. We do not perform our jump here. We check the bonus level, check game mode. Okay, now we're checking our special value here. It's not 0. So we jump to 6193. We do not go back to the special word. Yeah. Then I want to know what the trigger is for this becoming 0. Why would that be a thing? Of course, I can't play the level because I can't play the game here. Like, I suck at the game, so it's hard to actually clear the level. I mean, I can try again, of course, but my power-up didn't work, though. That sucked. I have to activate it, I guess. So yeah, this is consistent with what we have been seeing when we load 101, right? So, I mean, I'm gonna try again, but I'm gonna cheat a bit. Where are my power-ups? I don't remember what the values needed to be. Yeah, of course I didn't write that down. Oh no, these are the I need to give these better names because these are the power-ups of all the rounds. Yeah, so this is round 1, this is round 2, and there's like 5 rounds here, and then you have a pointer to a different one. Current map data power-up 44, but I need to know how to activate it, and I don't remember when I do that. Wait, I have another one here. 44 is blink cards, initialize, okay. But I don't need a function, I need amount of power-ups activated. Yeah, I don't think I can easily activate it. Oh, we have a state. Okay, we have a state here. D238. solid hard. Okay, I don't know what the exact states are. Oops. But I'm gonna give myself a 10 here. Wait, let me... Yeah, no, it's not active. And of course I forgot to pick up the first one here. And now it's not gonna work because I changed the value probably. Oh, it does still work, okay. Oh, and that's the reason why the power-up didn't work, is because you have to pick up all the things. Oh crap, don't block me in. Okay, he's going to kill me. No, he's not. Okay, now let's see what happens to these values here, right? So we have, where are we here? 65, 66. Oh, they stay on 65 though. So this doesn't get overwritten. I mean, and we're not going to, so we're checking this. Okay, that's fine. It's not a bonus. Oh yeah, yeah, of course. Wait, wait, why did we not? Okay, let me save this one. Oh, it's only on a level 101 apparently. Yeah, we're comparing with 65. It was 66 and it jumped 6 to so there's something weird. We have to be in mode A, in type A. We cannot be in a bonus level, and the level has to be 65, meaning 101. And only then do we check whether this guy is pointing to is 0. And if it is, we ask for the password to be, the special word to be entered. I don't remember what this one was though, HL. Oh, that's the level number. Okay, so we go to current level 1, and we jump to, so this function 6193 is show enter special word screen, which I might as well name. So what is special about round 101, where if you die, you get to enter the special word again? Right, so is that the case? Let's go back to this one here. So I'm going to enter it. It both becomes 65, right? So if I die now, do I go to the special word screen? No, right? So yeah, we're checking with 65, which is the case. We don't jump. It's not a bonus level. We don't jump. Type A, we don't jump. Or yeah, wait, if it's, no. If it's type B, we go to level 1 for some reason. So in type B, there are, I don't understand why we, right, in type B, we immediately go to level 1 if we die in level 101. And specifically only 101. I'm going to try that first. So I'm going to go to level B, or state B, type B, sorry. So type B, I'm going to have to play the first level, but then we will jump to Level 64, do I have to play that one? I guess we do, but that's fine. So I'm gonna go to, no, I just have to die in 65. So I'm gonna go to level 101. But I have to pass through the door, of course. Wait, but 65, that's not going to set 65. I need 65 in the other one too, though. Yeah, I need 65 here too. Okay, so now we go to level 101. Oh, this function is called not only when you die, but also this is more of an end level function, not a die function. That makes more sense. Because what would dying have to do with specifically round 101, right? Oh, no, I don't want you to do that, though. I was too soon, so I need to go... This has to be this for this function. Right, so we do have to jump, but we want to go now to 65. Wait, is that level? Oh, correct, bonus level. No. This... Yeah, I want to do... Because clear screen and map is going to load yeah, level 101. Okay, so yeah, okay, correct. So now I'm in type B, and I'm gonna die here, and we should return to the enter a special word screen, I think. Or maybe, let's see. So yeah, current level is 65, correct. It's not a bonus level. Type is type B. Oh yeah, type B where we're checking. Okay. Are we jumping here? No, we're not. We're putting 1 in the current level. Yes. And we're jumping to the main screen to clear screen and map. So we're loading level 1. Okay. Okay. Now I want to do... So are we still in type B? Yes, we are. Now I want to go back to... I want to go back to level 102 and see if the same happens, and I don't think it will. So that is a very weird thing that only applies to level 101. Okay, so I'm not going to change this value yet because we have to pass this check here. I just want to warp. So now, yeah, now we're here. Now we're going to go to level 102, right? And this should be on 65. That's fine. That's being set as soon as you go to, if you enter the special word correctly. So yeah, now we're going to level 102, and we're going to die here and see whether we end up in level 1, which I don't think we do. So we're going to die here, and I mean, how I'm going to solve this level though. if you have to solve this level, like how? I guess, do you get, yeah, you get, but I'm gonna die immediately, that's fine. Right, so now our current level is 66, which is 102. We are not 65. So yeah. And we get the rematch, like, what? That, I don't think that's known though. Like in type, the condition has to be, it has to be type B. You have to die in level 101 and you get reset to level 1. That's crazy. Okay, I'm gonna try this from scratch because I can force this by typing in the password, right? So yeah, let's reset that these values are normal again. I mean, this doesn't even get reset though. Like, when does this get written to 0 again? Okay, now it does. Okay, sure. Oh, right. I can't do that. I don't have a password and an enter password screen. Wow, that's crazy. So, oh, wait. Oh, wait. Do I even have a chance to play the last 5 levels in type B? That might not be the case. Right. So if I play and I go to level 100, I guess I'll have to finish it though. We'll see what happens. Yeah. I think I know what's happening here. I mean, it is quite clear though that that code is specifically for not necessarily dying. It's level ending. Like it's not. There's no dying involved necessarily. It's like going over the exit is also the case. But yeah, I'm not even sure you can go to you enter the special word in type B. And if that's the case, then it makes sense. So I'm going to exit here and we're going to jump to not here, but actually let me put one here and let's disable the others. Well, no. Okay, no. So I'm going to go to level 100 and see if I can finish that level. I cannot, so I'm gonna fake it. And now I'm gonna see what happens. Okay, so our level increased to 65, which is 101. Oh, right. And that now has 0 in it, so we're going to level 1. Makes sense. Right, so that's why it's there. Yeah, compared to 65, we're checking it's a bonus level, doesn't matter. Oh, and immediately, wait, did we go that quickly? Oh, bonus level. Oh, no, we're going to bonus level. Yeah, of course. Bonus level 14 here is 20. Yeah, of course. We don't have to jump to level 65. We have to jump to the last bonus level, but that's fine. So we're going to continue, load the bonus level. I always forget about this one. And we're just going to remove the timer. Okay, so where's the timer? This one is a timer 5 seconds. Okay. And now we are in the state where this is 0. This never gets set because it only gets set to 65 when you enter the special word. Right, we are in 65. We are in a bonus level. Well, no, the bonus level has been disabled. Okay. Now we're checking, is it type B? Which it is, right? We're putting 1 in the, okay, we're putting 1 in the level and we are jumping to the clear screen and map. Right. So the 5 last levels do not apply to type B. That makes sense. Okay, sure. That was the type B stuff. Now, still, what's up with... We didn't even check this one here. So we're talking about type A. Yeah, we have to end up here, right? Checking C807. So type B is out of the question here. That doesn't matter. Hi, Toby. Sure. I'm looking at the what happens inside Eggerland, and right at this time, we are looking at what happens when warping to the last levels of the game. Specifically, wait, let me see where I was. Of course, that I forgot now. So there's strange stuff happening here. We're trying to determine what this piece of memory does, like this 1 byte. It's a very specific situation in which that one gets set. And I'm trying to figure out what it would do, right? What it would mean. It gets set after level 100. And then it's untouched, seemingly. It is checked whether it's 0, and if it's 0, we continue to the next level. Like it's a bit complex, but I haven't figured out exactly why this gets set and why this gets checked. So I mean, we found where it gets set, and it gets set here, and we found where it gets checked. But why is the question, and that's what's bugging me. So yeah, we do set it at the same time we reach level 101, right? Loads 65 hex in the accumulator, and we both put it in the current level and C807, which is our thing that we're testing here. So it gets set during level 101, and it gets checked after dying or completing the level over here. So we're loading C807 in the accumulator, we're checking with AND whether it's 0, and then if it is, we revert to level 1, sure. But why would that happen? That means that there is somewhere a trigger that puts C807 onto 1 or onto 0. And I don't know what that is. Well, I'm not sure. So and the effect of that, I don't know if it's a check. It sounds like a checkpoint, because what ends up happening is you get the password enter screen again, and that doesn't make sense. Wait, so let me see. I don't know why it broke though. but that's irrelevant. So let's see, or the demo what was running. So if I enter the special word, this is a special thing at the end of the game where you access the last 5 levels. You have to have the big word here, like the special word, in order to go to the last 5 levels. And you accumulate those 10 sprites while playing the first 100 levels, right? So this gets set now when I complete the special word, right? So that now they're both 65, which is a 101, right? So if I finish the game and I'm going to cheat here, I'm going to open the door and I'm going to exit and I'm going to go to level 102. Well, so wait, let me show you. So it's not 0, right? So it's 65 as it has put it itself. So the game has done that. I'm going to go to round 102 and that's going to work, right? Right, so let me continue here. Yeah, so we're at round 101. So let's do that again, and now put it on 0. So before hard. So again here. Okay, I'm gonna open it. I'm gonna put it on 0, and I'm gonna cheat again and open the door, and I'm gonna leave, right? And now I think I'm going to see the enter password screen again. I'm gonna play here. No, it doesn't. Okay, that doesn't make sense. Okay, let me try that again. I thought it was gonna show this screen again, which is what I thought was triggering that. So we have 65 here. I'm gonna change that to 0. I'm gonna open the door, and now we're gonna step through the code. Okay. So yeah, this one is now 0, right? So we are checking the current level and checking, oh, it's 66. Wait, are we in? We've already incremented the level though. How is that possible? Wait. I'm in the wrong level. So I'm comparing to 65 and by 66 here. It already incremented, so it's not going to do this entire thing. Okay, sure. So how does that work then? Do I have to do it at the end of round? Oh, wait. Yeah. That makes more sense. We have to do it at the end of round 100. Right. Okay, so let me get to round 100. Now it makes more sense, because at the end of round 100, or more specifically the bonus level, I don't think if I have that, do I have bonus? Yeah, right. So at the end of the bonus level, this is between level 100 and level 101. We have a bonus level, we have level 65, but this is 0 though. Okay, so let me play this and let's remove the time here, 4 seconds. So let's see if this now gets set to 65. Okay, so we have the special word. Okay, oh, we get the special word. We are in 65, okay. We are not in a bonus level anymore. Game mode is type A, we're not gonna jump, or we are gonna jump, right? And now we are checking this value. It is 0, so right, okay. So it is 0, so we are now showing the enter the password screen, which is what's going to happen now. Right, so we are going to, wait, are we jumping here? The accumulator is 0. We're loading 1 in the accumulator. Okay, that's for this function. Okay, sure, that's the parameter for this function. And now we're showing the enter special word screen. Yes. So this is a trigger to show the special word screen after after level 100, or after the 20th bonus level. And indeed, if we enter the special word, which is this state. If we enter the special word correctly, it puts 65 in there. Yeah, because I have a write watch point. Well, no. Why did it stop here though? But in any case, it's going to load 65 in the current level. Right, and in this. I think this is just an optimization while they are, I mean, they're putting the same value, 65, into our special variable here, but it might as well have been a 1 because we're only checking that for 0, right? It has to be something other than 0. And this will prevent, I think, us from seeing the special word screen if we complete level 102 and 3 and 4 and 5 and 101 for that matter, I think. Yeah, so right, of course there's two ways of reaching that function, and that is either successfully finishing the level or dying. And if you successfully finish the level, then it immediately gets incremented to 66, but if you die it doesn't, and then this thing matters. Okay, so if I die here, right, it will not show the, so I'm going to continue here, it will not show the password screen, but if I die here while this is 0, it will. Now it will show the screen. But this is a situation that cannot happen, right, it shows the screen. This cannot happen because as soon as you enter the special word correctly, it puts a value in here, right? So the state I'm seeing cannot happen in the game, right? So even if I put 1 in here and I die, I won't see the screen. Right. So yeah, this is like a fancy boolean in the sense that it just has to have a value in case you die on level 101. Yeah, that makes sense. So yeah, this is C807 is has special word screen been shown? Right. That, I think it makes sense. Yeah. Okay, that's another one we figured out, I guess. Yeah, so we have a jump point or something to jump to, which is this one here. If we want to make a function to jump to a specific level. Last time I tried this, it crashed, but I think we can do this now. So I'm randomly stopping somewhere. I'm going to this location and I'm going to put the accumulator to the level I want to go to. Or in this case, it's like, well, let's put it on 10. Can I change this? Wait, let me give a hex editor for the CPU registers. Let's put that on 10, level 16. Can I now jump to this function here, this position? Set PC to 6193. And if I run, do I load 16 or do we crash? No. Oh, wait, no. It has to have set the value in the memory. Right, okay. So it's not the accumulator then. No, of course not. Even though it's actually here. No, I have to jump here. Except it's not ideal because the second one will be set as well. So I just have to set a value in memory then. Okay, so let's stop it's 6193, right? So let's break. Well, let's start the game and let's break at a random point. I'm going to set the level to where I want to go, which is level 10, as in level 16. And then I'm going to jump to this point and see if I can get it to not crash. I mean, it does work though. That's interesting. Now I have to make something to immediately do that. Because this initializes, I think, right? Clear screen and map. I think these guys initialize. I do have a function though. I wonder if it's called initialize or initialize round, reinitialize overall game state. That's for the menu, I think. Initialize round. Yeah, 6716. Let's see if we break there. 6716. Let's see if we break, and I do the same thing now. I'm going to put, let's start the game, go to level 32, and let's jump to our function here, clear screen and map. Yeah, so that initialize round gets called, so everything should reset to whatever it has to be. Yeah, so that's a thing to jump to. Now I only have to set this memory location and jump to and set the PC to the program counter to that specific address, and we have a warp function. I don't know how it works with the scripts though. I have to figure out how that works. We have trainers here, but I don't know if I can ask for a value, like if there's conditions, because I have to ask which level to jump to, right? So I don't know if I can do that, and I don't know that's in here. Like we have checkboxes, but I don't know if we have inputs. I mean, I can check in the code, of course, to see what was it called? Trainer data, trainer definitions. Yeah, so we have depokes and stuff, but I don't know if we can query values from the user. I mean, these are just pokes and peaks, I guess. Yeah, I don't know how this works. I have to figure out how this works. If I can make a trainer that gets that asks for an input here. And then also an action button, so I can jump there. If I can't do that, then I have to write my own window here, which is not that hard to do. Yeah, because these are just pokes that I see. I never see something else than a poke. I mean, you can run scripts though, so I don't know if trainer is the best option for that. Wait, these are scripts, right? Metal Gear Overlay I've seen. Yeah, wait. So we have scripts here that get loaded for some reason. These are listed in the menu, so I could run, but the problem is I don't know TCL or Tickle or whatever. tool command language. I've never programmed in this, so it's gonna be tough to write something here. We don't need for loops, we don't need if clauses, we just need to set the program counter and jump and set a memory location. But this is OSD stuff. This doesn't do anything with memory. Okay, we're writing registers at least, so set well, no, debug write, I guess, yeah, debug write is going to be our memory write function. Yeah, I'm gonna look into that. I don't know how to do that, but yeah, we probably can make a script that, I mean, I still need an input thing though. I need to ask for the level to jump to warp to. So I might have to unless I can get an input here from this, perhaps, I'm not sure. Can I turn it off again? Yes. Yeah. But that's a good target, so I have to note that down. Warp function target set what's the name, current level C81B to level to warp to, and set PC to 6193. Syntax highlighting for what exactly? Because the code had syntax highlighting though, or is it from in a symbol file that you mean, like this file? I don't know if there is a symbol syntax highlighting for symbol files. Yeah, I mean, it didn't suggest it either, so perhaps it doesn't recognize the sim file extension. But I'm not really missing that in the symbol file though. That's just fine. And also, I'm gonna make something that puts my information in a JSON file and then converts it to a symbol file, because this isn't ideal. I have to do stuff like this. Like I have an array of 100 things here, and I have to specify each byte manually. That's not productive here. So I'm gonna make something that converts the JSON file and like process it into a sim file, so I can like put arrays and stuff in a way, condensed way in a JSON file. But yeah, this doesn't have syntax highlighting. Okay. So yeah, we have warping, we have the passwords. What else did I want to look at? There were some unknowns though still, like this one we don't know, these guys we don't know. this one we don't know. Yeah, this was a map to the arrows and bridges. Okay. Oh yeah, this one here. Yeah, of course. We looked at that one too. So let's go back to the start. And I think that it gets set to 0. It does not. I thought it was checked though. That's weird. Password selection. D97C. Yeah, one gets put in there, but we're not in the password screen, we're in the level screen already. Are we in a known function here? No, it doesn't look like. Also an unknown here, FEDB. Bonus level data. That's interesting though. Like, let's see what this function, if we stop here, I'm gonna remove this one and these two. Let me restart here. Okay, we're in type A. We don't have a password. It doesn't stop here. Okay, so we are jumping in here from somewhere else. So I'm too high here. That's fine. Let's see if we can find a start of the function here anywhere. Okay, it's the after this call. Okay, so we must be jumping here. Oh yeah, 875. It's this one here. So we're skipping this for some reason. Yeah, based on it being a bonus level, then we're doing this apparently. Otherwise, we skip that. Okay, so we are here. So we're looping here. A84D is here. We're doing something 5 times, it seems like. For I don't know what patchy assembler is. Oh, it is? Okay. I mean, I'm not really missing it though, because it's only the EQU that you have to like look at, right? It's like one line only has like 2 bits of information. Like you have the name and you have the value. So I'm not really missing it. But yeah, I think I'm gonna switch over to a JSON file with all the data in anyway, so I'm not really worried about syntax highlighting in that file. I mean, it would look better, of course, but yeah. Okay, let's go a bit more up here. I'm pretty sure we're executing all this stuff. Okay, another jump. To 885B, that's here. Okay, so we're skipping that. Sure. We're having another jump here. Let's take the jumps though. And this one. And this one. Oh, this one jumps to, okay, sure. So perhaps the function starts here. So let's see. Go. Yeah, it does. Okay, so yeah, this is an unconditional jump. 24 was 24. Switches indicate a slot at indicated page on perpetually. Wow. Enable slot. Sure. Okay. Yeah, the function starts here. So we're checking whether it's a bonus level. Okay, we're checking it's a bonus level, or we're checking it here, and it is not a bonus level. Okay, and we have the pointers to the level data as well. Sure. We're checking if it's a bonus level. And otherwise, we're pointing to the bonus level data. That makes sense. We're loading the current level. It's zero-based indexing, so we are loading, or we decrement the current level. We're comparing it with 5. That's bonus related, I think. Wait, no. So the pointers to the the pointers to the level data have stuff per 5 levels. So if you go look to 6D56, this is our pointers to level data and pointers to bonus level data. We have 16-bit pointers, right? So we have 2, 4, 6, 8, of course, 8, 16, that's 32, and 8 is 42, right? 41. Am I correct here? 1, 2, 3, 4, 5 times 8 is 40 plus 1 is 41. Why do we have 41 pointers? Because we have 41 times 5 is 205. That's too much though. We need 105 levels. Because yeah, if we go look at D5F8, D5F8, that's our first level here, right? That's round 1 map data starting with power-ups, and then we have Lolo start index, exit door index. Yeah, okay, so this is our array of thanks for joining. So yeah, we have our level pointers. We're comparing this with 5, I guess. I mean, we're going to do we're going to determine which one of these pointers we have to get, right? So it's not 5, so fine, okay, sure. I mean, I guess it's checking whether it's above 5, and then we're subtracting 5, increasing the pointer, and doing that until we are under 5, and then we can find the correct pointer, right? Like we're mapping 1 to 100 per 5, so 20 times, to an index in from 0 to 19, I guess. Okay, so we found we're level 1 now, round 1, so we need the first pointer, which is D5F8, which we haven't loaded yet, but we will now, I guess. So 6D56, first pointer gets loaded into the accumulator is F5. Then the next one, like we're building that pointer, right? D5. And okay. We're loading whether it's a bonus level, sure. Wait, D5, F8. Yeah, we have that in HL. So we're pointing HL to the map data. It's not a bonus level, so that doesn't matter. We're calling for A4B0. I don't know what that one does. And we're loading one into our mystery value. Here it's D97C. Yeah, which already contains 1. For some reason, it gets overwritten. I'm going to see what A4B0 does, though. A4B0, that's just after load map data into current map data. Oh, which gets called, okay. Oh, we're loading one power-up here. Like we're loading the power-ups and the start index into the current map data. Okay, sure. So based on the result of this little function here, we're doing it again. Why are we only calling this one once for the first power-up? That's a bit weird. So, okay, so this function gets called with something else in HL. Okay, so round 1 map data power up 1. And what do we have in, that is D5, F8, that's the same pointer. So we have the same pointer, but for some reason this, so for A4C6, what is A4C6? That's this one. That's weird. Okay, so we're copying these values in the current map data, sure. So we're actually loading the map and we're putting that on 1. Okay, fine. Okay, maybe this is connected to this function, so we're loading C000. That could be something video related to, let's go in here, and E0. Okay, these are the pointers to the arrows, bridges, inanimate objects, and again the arrows and bridges, I guess, to iterate. I guess this copies that data over, fine. And we return. Now the question is, does that value get set elsewhere? I'm gonna finish this level with a save state, of course. Let's see if we break now. Thanks, Toby, for following. I hadn't seen that. Yeah, again. Oh, wait. Oh, no, that's our function. Right. That's the start of our function. That's fine. And we do write 1 in it again, but nothing else. Maybe it's bonus level related. Let's see if we can load level 5 before exit. That should give us a bonus level. We are at the start of that function. No, we're at the 1 again. Okay. Okay, then simply let's see. Let me remove the timer here. Oh, wow. So this is arrows and bridges that gets completely reset, overwritten by stuff for this screen. That's weird. Again here. Okay, now let's see if we can see where it gets red though. So D97C, read memory. Turn that on. Let's go back to one of the first levels here. This is writing, which we are going to disable now. Okay, it's not red at level initialization. Let's see if it's red at exit. It is not. Let's see if it gets red before a bonus level. Oh crap! That sucks. It removes my watch points when I load the state. That sucks. Okay, it doesn't. Let's do the same thing with the bonus level. Oops. D97C. No, it does not. That's weird. Nor here. Maybe in the high levels. Wait, let's go to an easy exit. Let's go to level 101. No, I don't want to be in game mode 1. Oh, no. Okay, round 101. It updates immediately. I need to go to... Yeah, I need to add my watch point again. That was what I was thinking. D97C. Okay, let's go to level 102 then, I guess. Aha. Wait. No. Oh, crap. I did write memory. Okay. Now I need to do read memory. I thought we had something here, but apparently not. I mean, why would that be set to 1 if we don't do anything with it? Okay, where are we? I can't find my memory here. 8. No. I need to find the hard framers left. D1F2. Okay. Load over treasure ground or exit tile. Okay, that's weird. It's over bridges as well. Okay, that's interesting. Because here it's 0. Yeah. Oh, this affects bridges too. Yeah, that's so 5 and 4. Tile 1 or 2. Okay, but that's the same for exit. So yeah, wait. So this is the thing we can move over. Yeah, 9 and 8, B and A. So these are the tile indexes of the stuff we are over. But bridges are also there. Treasure crown, exit tile, or bridge. Yeah, that's applies to that as well. That's why I couldn't find this guy here. So exit door is open. Does something happen when we die? No, it does not. I'm going to have to write a function that exports this to a file, so I can simply search for D97C though, because this is silly. I need to simply find references to this memory variable, and I just need to export this data, right? Or create a find function or something. Because something has to be writing there. I mean, it could be in the menu perhaps, although that doesn't really make sense. Like, or in type B perhaps. Let's see. I mean, it was password related though. That's what's weird. Again, that screen is completely used, and I don't see any changes here. Weird. Yeah, so this value is, wait, my watch point is gone again. D97C. Nope. Now it's broken. So it is actually used. Of course, it's not there for no reason. That's couldn't handle that. Okay, never mind. Oh, is it completely bored? Okay. Okay, now it's completely gone. That's a bit weird. Don't know what it is, and it gets set when you enter the password, right? And you do a password selection. Yeah, immediately it gets set. Let's see. Yeah, it does get set every time. if I die, it gets set. That's a weird one. Good, let's go check the main game loop or the initialization function again. And because that one has some stuff around it that we didn't know about. So load round. Wait, that's interesting. Well, yeah, no. That does make sense though. We have some unknowns here still. 619F gets called. 619F. We have seen this one because we're close to load round 101. 619F, do we not jump here? Yeah, here as well. Okay, this is initialization related because we call this from load round 101 and our generic load round. So we're calling 619F here, which runs this entire thing, and then we're jumping away after this returns. And this returns after this jump 652. Okay, we do jump here 652F, and okay. So the return happens here. So this calls copy VRAM placeholder sprites into VRAM. So this, wait, okay, this is interesting because this function is going to have a similar name, right? It's only calling one thing, and it probably loads like a different pointer to do this. So copy VRAM placeholder sprites into VRAM. Oh no, we do have one for copy prep for VRAM into VRAM. Yeah, this specifically goes to the placeholder sprites. Okay, so yeah, let's go back. So we're looking at 619F, right? And this jumps to 5.6. That's a BIOS function. Fill VRAM with value. Where was it? Here with D1. Okay, so we're filling the VRAM with D1. And 1B00 and 0100, those are those not these base addresses? No. No. So we're clearing current bonus level. We're checking whether we are in demo mode. And showing the main menu, if that's the case, I think. We're calling AF03, and we're showing the main menu. Conditionally on the carry flag, okay. And then we're jumping to 40ED though. Like this stuff doesn't get executed because this is an unconditional jump unless 61BE is referenced elsewhere here. No, it's not. Like it's weird that it does filling of the VRAM and setting the bonus level in the same function, right? Like this is level initialization stuff. I mean, there's other places where we set values to their defaults. That's a bit weird. I'm gonna check this one though, because I want to see what it does after that. So I'm gonna reload a level. Okay, so we're at the start of this one. That's fine. Let's just jump here. So we're filling the VRAM. Okay, and I didn't want to jump here. Okay, let's continue then. Okay, so we oh, we're back here again. Oh, wait, does it not return? Oh, it doesn't return here. It just does this. So this is a different function. That makes more sense. Yeah, that makes more sense because yeah, this is bonus level stuff, and this, like I said, this was fill the VRAM with D1. It never gets here. So this is a different function. Yeah, okay, so yeah, this is a different function. Starting from here, I guess. Okay, so we're doing this a couple of times, which is also weird. Like it's painting things like in chunks, but all this does is like it's literally the parameters to this function, right? So it fills, oops, it fills the VRAM with A is the data byte being D1, BC is the length of the area, which is 100 hex, and the start address is 1B00. So I don't know what 1B00 in VRAM means, but we're writing, what is it, 100 hex. 64, wait, what? Oh, no, that's decimal. Okay, 100 has 256 bytes of D1 into the VRAM at address 1B00. So if we go look at the VRAM and we go look at 1B00, this is this one. It already contains D1 and stuff, right? So I can't write here. Yes, I can. Right, so it is like it is stuff on the screen here. Wait, let me write values that I see. Like I don't know what exactly this is. Oh no, 256 bytes. I'm too low. I'm too low. Like you see, is like this is Alma pointing right? So I'm not sure exactly what this is. I need to look this up though, like because I don't know exactly VDP registers. Oh right, name table is 1800. Was that 1800? No, 1B00 is it? Okay, sprite attribute table. Okay. So this is reset sprite attribute table. I don't think I can find anything immediately. Yeah, but this is something I have to look up. Okay, so considering this writes to 1B00, which is the sprite attribute table, I'm going to assume this is a reset function. 619F resets the sprite attribute table, I assume. I mean, I do need to... This register define, okay, sure. That's the address of that one. Screen 1 to 3 is 1B00, okay. But I need to know about the contents though. Okay. Okay, so X, Y, character number, and color code. Like that's the same thing, right? Y, X, style, sprite index, and color code. That's the same set of 4 bytes we've been seeing. Right. So, I mean, Lola should be in there though. I'm going to reset because I screwed with the numbers here. But does this reset? Yeah, it does. What was it? B1B00. So starting from here, it's going to give us some sprite data, right? Yeah, it resets to D1, and then so Lolo is positioned at 0204, but we need to use sprite indexes, I think. So convert from the different coordinate systems. Yeah, tile coords to sprite coords. Did I not write the algorithm here? Oh yeah, I have a different function. Yeah, here one. So y is double double plus 2, and x is divide by 2 plus 4. So 0204. So let's do the calculation here. Y is 2, so 2 times 2 times 2 plus 2 is, okay, no, 2 times 2 times 2 plus 2 equals 10a, which I don't see. Oh yeah, I do. So that would be, and then x is what? That's 04 to start with. 4 times 2 times 2 plus 4 is 5. I don't see 5. Yeah. Maybe when I start a level. Okay, that's, yeah, the flickering is gone now. That's at least good. So it's weird that they all change though. Like, why? Uh, 10 was x. So that's at least x, and that's y. Okay, so they start, I mean, for some reason they're duplicated, right? I mean, this is y, x, the sprite, and the color. If I change the color to, oh, that's cool. So I don't know which one I can, I mean, it's constantly overwritten, I assume, right? So 27, okay. Oh, and oh, yeah, we have 2 sprites, one for the eyes and one for the body, sure, because the eyes are white, right? So this is the eyes. I can make them not quick enough green for a very small fraction of time. But for sure, this, I mean, if I remove it, I don't think I can though. Like, no, I can't. Because it always gets continually overwritten, right? I guess maybe it still updates if I pause it. I'm not sure. So does this still work? No, it won't update the video frame. But that does mean, did we skip here? Okay, we did. It's 619F. This function resets what was it called? The sprite attribute table. .619F is reset sprite attribute table to D1. I mean, it resets the sprites, right? And indeed, it jumps away. Okay, then we have a similar initialization function, 699C, which does more. Okay. So let's go back to our game loop, our load round function. Right, so we do reset the sprite attribute table, we do initialize round, and then 6BA0. Okay, this transfers blocks to the VRAM. I'm guessing this puts the stuff on the screen. Then at the end we call D8. Oh, that's the input function, I think. Yeah, current trigger status is spacebar. Okay. That's fine. And then we return. So it does an input check as well, or an get input. And it starts in the middle here. So it there's lots of other stuff here as well. And it falls through apparently. But we start at 6BA0. Let's see what 43BF does. 43BF. Immediately calls or jumps to 6CB8. Okay, not sure what that does. Okay, let's again look at the addresses, right? So LDRVM block transfer to VRAM calls 5C as well. So 5C is the one we were looking at. Yeah, so block length. Oops. Yeah, these values are just passed. Okay, so let's see what we are sending to VRAM. No, I want this one here. Whether it's initializing something or I think it's copying the entire level though, like the entire level to VRAM, as in the tiles perhaps. So let's look at the addresses and see if we can find an address we recognize. The address in VRAM would be DE, and PC is the block length, and HL is our RAM. So DE is the block length, and BC was the target, right? BC is block length, DE is VRAM address. Oh, so we're writing to 3800. Okay, let's see what we have here. What was it? 3800, 3000. Okay, that's sprite pattern table. Okay, so this writes the sprite pattern table coming from C00 for 800 hex bytes. So that's hard-coded values then, because C000, that's going to be in the ROM, right? Okay, that's blank. What's this? Oh, wait, what? Oh no, I'm in VRAM. I'm in VRAM. That's a bug, because I shouldn't do that in VRAM. C000. Okay, what is this? Okay, yeah, this is a sprite. What was it? Sprite attribute table? Sprite pattern table. Okay, the patterns of the sprites. Okay, and the length was 800. 2 kilobytes. That's C800, of course. Oh, yeah, okay, so these are all the sprites until here. Like, that's the last one here. Okay, so C0000 that's the sprite pattern table that gets copied over. And does this change? I don't think it will though, because we're in. Yeah, no. We do change this though. So let's reset. Okay, we break. That's fine. No. It does change. Okay. I mean, I guess we don't have sprites on this screen, yeah. I wonder if that's location-based sprite pattern table. Okay, so that's indeed just simply well, there's none in there now, so I don't think that this is being copied. But once we do load a level, then this these patterns here get filled in, right? Which is what is done now. Okay, so now these guys are loaded. Now, question is, I mean, I cannot overwrite this stuff. I'm assuming that I'm editing this first skull here, but that won't be updated immediately. Okay, I'm gonna load before exit here, and I'm gonna make the same change, and I'm gonna exit. Oh no, the first one doesn't have any data, of course. Oh no, it's this one. It's this one. Yeah, does it get overwritten? Yes, it does. So it's coming from somewhere else, from the ROM, of course, right? Where else? But yeah, these are the sprite patterns that get then sent to or copied in bulk to the VRAM. Okay, I need to add comments here. This. I need to comment this stuff. Because we are doing, wait, 6B38. We're doing multiple copies here, and I need to know what all we are copying though. Because these are interesting pointers, like I'm going to name this one. But like I can't do 2 kilobytes of like 2048 entries in my symbol file here by hand. No, that's not really possible. So yeah, we have here this is sprite pattern table. That will be copied to VRAM. Right, so that's the problem is that it's 2 kilobytes, so I can't really manually add them, all of them, but like they should all be brown. So I can all mark that. And then the next one is, wait, where were we? Here is the top. This is the first one. Right, okay, that was already written. So HL contains, so C140, C140 is this one. Also weird because it overlaps, so that's not good. Yeah, BC was 800 hex, but that's, I mean, this looks like a different pattern than this guy here. So that got written, 800 bytes got written, and then this is 80 bytes hex. To 0780, which is a number I didn't see. Yeah, as I thought. I mean, it could be in the pattern table though. Which would be tiles then, I guess. And then the next one is C540 is this guy. Again, 80 hex bytes to 2780. In the color table somewhere. Not as a start though. Yeah, so this 2048, I mean, it is being copied though. That's the weird part. Like it ranged all the way from here to here to this one. Not sure. All right, that's going to be it though. Thanks for watching. Until next time.